Really appreciate everyone being here. I was going to start out with a little introduction with Amin Solju from Mangan Inc. And then we'll come in and have some conversations about safety and introductions. Have everybody kind of do an introduction. Go ahead.
Right. Can everybody hear me? Sounds like it. Yeah. Good morning, ladies and gentlemen, esteemed guests from all over the world. Thank you very much for attending your users group. It is an honor to stand in front of a group which is characterized by brilliance of mind and also fervent commitment to safety, process safety. I'd like to thank everybody for traveling from various distances to come here today. Greatly appreciated. There are many also in off hours overseas logging in. We're trying to make this as engaging and interactive as possible to be able to exchange ideas and share topics with each other. I also like to give a shout out to the great Motiva team for graciously hosting this in their magnificent building. Thank you very much. Ramon, Mark, Mitch, and a few others here. Thank you very much. We have put together a comprehensive agenda today for the group with a lot of contributions from the users, which makes it even greater. I'm very keen to hear those. Some of them are going to be magnificent. The MSS group is going to go through the new developments in their roadmap, the developments in the product, and also I think they're going to be talking about our knowledge-based library, which is a new highlight of our offerings. We're going to talk about how we're going to connect our customers as well as partners to that library and so they can use it. In the past 2 years, we have invested quite a bit in API tool developments, partially because we needed to connect to customer databases and partners databases. But also that has facilitated our future endeavors into generative AI. So by the virtue of this connectivity, we believe that we can provide connection to up and coming new generative AI applications in a very sensible way, because it would be using customers' proven data, and it's for people who are interested in it. It's not going to be something that we part of the complete package, but customers that are interested. I think Jeremy is going to talk about that a little bit more. The other thing I wanted to talk about was, my hope is by engaging in conversation, we make this a good meeting for everybody, productive and informative. When I look around the room, I see companies, representative of users, operators, and representatives of consultants that compete in markets with each other. But what's remarkable is it's an unwritten rule, almost an understanding, common understanding in our industry, that safety transcends competition. So when it comes to safety, it is very inspiring to see in our industry companies that generally compete, they collaborate, they cooperate, they work with each other to make their plants safer and for the betterment of the industry. So that is a feature that is, I think, probably not exclusive to our industry, but it's not very common elsewhere. I don't want to take up too much of your time. I know you're here to hear more important things. So with that said, I thank again everybody for being here and looking forward to talk to you during the breaks.
Thank you, Amin.
Thank you. Okay, good morning, everyone. Welcome to this event. This is the first Mangan User Group. We're going to be basically sharing information about the different modules that we use as an end users. So This user group was requested by during a meeting that we had with Amin and Mark Walton last year. So we know that beside to Motiva, there are other companies using this tool, and that would be great. We can start having this type of event, hopefully every year, and I hope that this is the first one, but not the last one. I got to say thank you to Mark and Amin to basically have this event today. So the plan for today is we're gonna go basically to different presentations from different end users. So and we're going to be talking about experience that we have with the tool, issues that we have found challenging, and how we have solved the problem in order to share this knowledge with the rest of the folks here. So let's talk about safety. Now, safety of the building. So I don't see a mouse here. So okay. All right. So we have some safety instruction on this building. So in case of a fire alarm that we have in the building, so the instruction is follow the exit sign. We will meet a fire garden. So fire gardens are on each floor. Once we follow the exit sign, so we will meet with the fire garden. They will basically give instruction about where to go. Go to the nearest stairwell. Uh, Yeah, the last one is information about Wi-Fi and restrooms. So you can see also that on the whiteboard that you have information about the Wi-Fi for those that haven't connected yet, and also the restroom. So for the restroom, you take the exit, go straight, and you will see the women's and men restrooms. You have to use those codes. So each restaurant have a password that you have to use to get access to the to the restaurants. So I don't know, it is part of the agenda to go through introductions to each of the attendees. So, well, I should have done that before, but my name is Ramon Morillo. I work for Motiva Enterprise. I'm a Information Program Manager, corporate for SIS. I have been with the company almost 5 years already. So,
Jeremy
Jeremy?
Lucas, Mangan Software Solutions, Chief Technology Officer and President.
Philip Tegnander, functional safety engineer for ES Baldwin. Worked with the wonderful people at MSS for about 4 years up until the start.
David Williams, I'm with Motiva, I'm SIS specialist. Mitch Murdoch with Motiva, I'm the SIS focal point.
Jerry Garlick with Motiva and SIS specialist.
I'm Stephen Kearns. I'm with Shell. I am a process and process safety chief technical authority and GMP functional safety certified.
I'm Ronak Patel with AKD Digital, certified functional safety engineer with digital initiatives.
Sunday Odalube, Nigeria Stream Petroleum Regulatory Commission, Health, Chief, Environment.
My name is Manuel Franco from Nigeria. I work for the Upstream Commission, regulatory body, and I'm the director for development.
My name is Mono Ladipo. I work for the Nigeria Missile and Downstream Regulatory Authority.
With the process safety team and the Nigeria
Javier Rincon, Viva Americas, business development manager and functional safety senior certified.
Joseph Odell with Viva. I'm a consultant, functional safety and digitalization.
Hi, I'm Scott Abraham with Steer Park. SAS
Do you want to use the microphone?
Oh, they can hear you. Yeah, they can hear me, I think.
I was going to dim the front row.
Yeah.
morning. Marvin Walton. I'm with Mangan. I'm the Vice President of Development.
Probably not getting his video.
I'm Harold Howard, Mangan also. I'm a strategic account manager and SIS SLM for Verizon. So.
Ron Pellegrino from Manganese, California, Long Beach, functional safety expert, as well as SIS engineer for our business.
I'm Mangan Software. I'm CEO of Mangan.
Stan Hirsch, Triad Process Control Consultant, SIS Specialist. Axel James, Triad Control, part of Plan.
Chad Schindler with Triad Control Systems Business Development.
Ayana Groby with Mangan Software Solutions and Client Success Management.
Dave Bay, Quality Assurance, Quality Control Lead, Mangan Software Solutions.
Chris Corey, lead SLM trainer, Mangan Software Solutions. It's great to see a lot of you guys again.
Matt Westall, Base Software Solutions, Technical Product Owner, SLM.
I'm Sean O'Neill. I'm with Mangan Software Solutions. I'm our SLM Solutions Manager.
Okay, thank you guys. I'm really glad to be here with you guys. Glad to see people from past life, especially. I'm going to say that the first time that I saw this software application was back in 2015. It's about no mistaken. So I got a presentation from Mr. Divanka from Mangan Inc. In LA, where basically they invited me from my past job to basically attend a presentation about this really nice tool. And that was Divanka that basically was presenting the tool. That was the first SLM version that at that time didn't have the Silcal engine. Basically, Divanka drove me through the whole, basically the whole modules. That was a very good introduction. He convinced me that day because those days I was in the middle of evaluating the different, solutions in the market to be implemented in my previous company. And after looking at the presentation, and also all the evaluation that I did was when they decided to go with the Mangan Software SLM tool. So at that time was the Mangan. So Process SLM or something like that. I think that was the original name of the tool, and then they changed to just Mangan SLM. So any questions so far? Okay, so I guess that let's move now to the first presentation. So I guess that this is not opening.
Sure, I'll grab it for you. You're down here. This one?
Yes. Let's ensure that this is the right rep. You said rep 2, yes.
Okay.
Good presentation mode.
Boom. Let me give you a little bit more light so we can see you.
Jeremy, probably get the microphone working.
Yeah, I think we can do that. Yeah.
I think that'll help.
You know what? It would be good. Let me see that can.
Here you go. You want to throw this in your pocket?
Okay.
Throw that in your pocket. Turn it on. There's a switch. Right there. Hello.
Yeah.
That's better. We'll get this.
Can you hear me now? Oh. Okay, let me see it. Okay. All right, guys. On this first presentation, we're going to be talking about our experience, basically, with the SLM implementation for our facility. So we have one very large facility in Port Arthur. It's a refining chemical complex. The refinery is the largest refinery in U.S. So we're really proud to be part of this big complex. We have a chemical plant that was acquired back in 2019. So we did an integration also for that chemical plant into our already established functional safety program that we had at the refinery. So what I'm going to be talking here on this presentation is about our journey. So because everybody probably know here, so the Mangan SLM is composed of a set of different modules that are interconnected each other. So we prepare a plan for implemented to ensure that we have a smooth transition from our previous software application that we were using for functional safety and the transition to Mangan SLM. That's why we prepared a plan, and that plan was basically have been executed by phases. And this is what I'm going to be talking about today. Okay? I just wanted to share a picture of my family. This is my wife and my beautiful kids. So my wife Nayi, my two daughters Valentina and Vanessa. That happened last year in Columbus, Ohio, during after my daughter's graduation at Ohio State University. So my two daughters, Valentina is 21 and Vanessa is 12. So I have a big gap between the two daughters. So, okay, so this is the agenda that we're going to be covering today. So I want to start first talking about the background, how we started this program, how Motiva Enterprise started this program for functional safety to be in alignment with the ISA 61511 or ISA 61511. Talk briefly about the safety lifecycle tool evaluation. So because this company also did some evaluations before deciding to go with the Mangan SLM. And then we're going to be diving into the different SLM implementation phases. So our journey as a company started back in 2004. And how it started? So this started in 2004. We still, or the company, Motiva, was still under, hold on, Jeremy.
Yes.
Can you help me here? Okay. Okay, I think that I fixed. I was showing a screen here.
All right.
All right, so in 2004, Motiva still was on their shell. They initiated kind of a corporate program to be in alignment with the recent release, first version of the ISA 6111. So Motiva, since it was on their shell, basically, they initiated the program for basically alignment with the ISA 61511. In America was ISA 84. The intent of this implementation was address the requirements around hazard and risk assessment designed for SIS. At that moment, it didn't include operation maintenance. So since each SEAL assessment process for hazard and risk assessment needed to be documented, ISC 61511 require documentation that basically have evidence that you are doing the correct work. So Shell basically developed a PC client server tool. So that was the software that Shell, I don't know if Shell is still using this software, but at the moment, so Motiva, Port Arthur basically got on board with this, and this is when they initiated this program. So back in 2016, this is when Motiva and Shell separation happens, and this is when basically Motiva starts thinking about we got to do something because we are doing a split Shell, and we got to start thinking about having our own functional safety program. At that moment was led by Mark Gordon, who is connected. So Mark basically started thinking about evaluating new tools in the market and also in alignment with the kind of a digitization process or digital transformation process for functional safety. So at that moment, Mark decided to use an independent contractor to basically evaluate the different safety lifecycle tools that were in the market. So after that evaluation, so Motiva ended, and because of the advice of the EPC, Motiva ended deciding to basically implement the Mangan SLM software. So in 2019, this is when we really started this implementation. And the first phase of this implementation basically was the initial instance configuration. That was basically implementing some of the modules that the tool has. And these were the modules that Motiva initially configured. So the instrument system module, the FSAs, the action item tracker, global module, and the management of change. So I'm going to start asking questions here to the audience to know who is using from the end user, who is using the instrument and system module, who is using the FSA module. Can you guys raise your hands so I can start basically asking questions about specific questions about those modules? Okay. You don't want me to be asking questions? Come on. I thought that this was going to be an interactive section. I don't want to be just me talking. I'm gonna start asking questions, guys. Let's break the ice. Okay, so at that moment we basically for the refining, so we did the process unit database implementation in the global module. So for 49 process units just for the refining facility. So that was the first phase. So back in 2020, so when we had the COVID time, so when we have a bunch of people working remotely, we initiated what we call the phase two. So what was the phase two was basically that was a mass data migration. So from we took the existing database from our legacy shell software. We took the whole database. We transferred the database of basically instrument protective functions into the Mangan SLM instrument and system modules. So that was essentially data dump, and that included basically all the data from the legacy SAS software. We did a database centralization, and we did also an initial SIP verification calculation for the identified safety instrument and functions. Of course, that nothing was perfect. We found several issues, and the most important issue that we found was related to some of the protective functions classified that after the data transfer were classified as a SIF. In the database, they were no seal-rated functions. So that was the first issue that we found, and we said, well, we got to do something here because we are classifying all those non-seal rated functions under the SIF category into the instrument and system functions. So we got to have a plan to start doing a kind of a cleaning in our database to take those non-seal rated functions out of the SIF under the instrument and system and do something with those functions that are not seal rated. And also,
take the information from SIF Pro and move it into SLM?
Correct.
So just out of a strategy question, why did you choose to take one SIS system and do it into that versus, say, taking a 5-year HAZOP revalidation and uploading one that has
that is a very good question, and the main reason we didn't do it that way it was because we also have a new PHA standard. We were in the transition process almost at the same time. So to initiate a total redo of our PHAs. So that's why we say, well, at this moment, that doesn't make any sense to do that. And at the moment, we didn't have the local module either. And we say, well, let's do a full transfer of the data into the SLM instrument and system module and wait until the PSN group start with their PHAs redo, no revalidation, and basically we will be preparing a plan for that transition. That was the main reason. Probably Mitch come.
I think the other reason too. That's exactly what happened there, and but the other reason too, our PSM group decided to go with PHA Pro just a little before we decided to go with SLM, had they gone with the same software, we would have gone exactly that way.
Yeah.
And so start with PHAs and just let it run through the whole system and just all be tied together at one time.
Yeah, part of the transition to the new PHA standard. That was a standard for PHA and a new standard for LOPA. Part of that transition involved basically moving to PHA Pro as a software for the PHAs, and the PSN team basically developed a new template for PHAs and LOPA. They were kind of doing at the time in 2020, they were doing kind of a pilot test. So about the new functionality of the template, and we couldn't wait because I know that there were some issue with the license. You probably can explain this better about the SysPro tool. We wanted to fully transition to Mangan SLM. That answer your question?
No, I was just curious. If there
Okay.
is a disadvantage, because I've also seen some of our divisions actually wait for the PHA cycle and then roll units one at a time into the software, and I wasn't sure if you found a significant benefit trying to do one SIS system to another versus wait unit by unit and roll them into the new.
Yeah, so that's the main reason we didn't have. So we were making transition. I said it doesn't make any sense to wait for this. Okay. The other is we also, when we made the transition from SysPro, so now that he mentioned SysPro, so from SysPro to I was just talking about safety, our legacy tool for Shell. But now we are in the middle of, well, when we made the transition, another issue found was that some of the seal verification calculation performed using the legacy software encompass every single output. We found out that in many of the cases we didn't meet the seal targets. Okay, so and that was another issue found, and we said, well, we got to do something with this to prepare a plan to remodel all those seal verification calculations to ensure that first, so we are aligned with the local requirements. Second, so we are properly modeling each seal verification calculation.
So that would be another advantage to dumping it into SLM, because if you waited 5 years for a PHA, you would go 5 years not realizing that your seal calculations are not accurate, and you're not either meeting targets or your targets are
right
not correct based on this. So there's another reason to transfer as well. SLM is very easy to read and use and to change data, and I think that's one of the advantages.
It's user friendly. Yep. Fortunately, we have three experts here using the tool. So they are the guys that you tell them, say, we need to review this seal verification calculation, and they are able to review, analyze, and make the correction. So.
You're also making the assumption that any of the operators here have a facility that doesn't have jabs. So.
Okay, so starting in 2021. Yeah, starting in 2021, we initiated basically as a consequence of issue found, we started with a process to validate the data. That is still ongoing. You said between 2021 2023, but it's still ongoing. So that we have a combined team from the PAMC, SIS folks, Mangan Software Solutions work through units individually to start basically validating the data brought over from the legacy SIS software. So this effort, like I said, is still ongoing. A lot of improvement, optimization we have been doing in our functional safety work process. Okay, so for the validation, so we use, of course, key functional safety documentation like a cause and effect, existing cause and effect, metrics, our SIS narrative, PNIDs, the initial set of LOPAs on the new standard. As a result, so we have now, we can say that we have a cleaner database. Most of the seal calculations are modeled properly. I can give an example of a issue that we found for seal verification calculation. I don't know if is anyone from refining. I think that we have a person from Total Refining. So I don't know how familiar you are with sulfur recovery units. Sulfur recovery unit have different streams, and they include like a natural gas, sour gas, acid gas, and combustion air, and they have a multiple final elements. So when we start reviewing the seal verification calculation on sulfur recovery units, we realize that on the SEALCAL modeling, we were basically taking every single output. When you take every single output, means that many of those outputs are not part of your success criteria to meet the SEAL target. As a consequence of that, in most of the functions, we couldn't meet the SEAL target. So we had to take an effort to basically meet with the process and process safety SMEs and the process SME from sulfur recovery, and sit down with them and basically first educate them about what we were looking for when we modeled a SEALCAL, and then basically get input from them about for each scenario that we are mitigated with safety functions. So we were the output that basically bring into a safe state. And this is how we start basically remodeling the SEALCAL for sulfur recovery unit. I think that was the unit most critical in regards to meeting SEAL target, correct? The SRU was the most critical. So and we have how many? We have 6 SRU units. Yeah, we have 6 SRU units. So that was another cleaning that we did on the sulfur recovery unit, and that was probably the best example to provide. So what do we have still pending? So we need to ensure alignment with the unit local report after each unit PHA redo, like I was explaining before. So now we have a program, a 5-year program to redo all the PHAs. So we are fully aligned with the PSN group. Anytime that they complete a LOPA or a PHA study, they provide the outcome to the SIS group, and the SIS group come back to the instrument system module to ensure that there is alignment between credit taken in the LOPA study for safety instrument and function, identify the SEAL target, and basically ensure that the SEAL target match with the SEAL target that we have in the instrument system module for the safety function. This is still pending. We also need to do another cleaning work, which is reclassify the non-SEAL rated instrument and function and moving those into the interlocks into the instrument system module. Any questions so far? Let me know if I'm going too fast. Okay, also in 2021, so we did the phase 4. The phase 4 was basically implementing SLM for the recent acquired facility, the chemical facility that is next to the refining facility. And that year we start doing some pilot tests. I'm trying to get familiar with the operation maintain module, which basically was part of our plan to start transitioning our process program from, let's say, paper-based and also from SIP into SLM. So we start doing some pilot in a couple of units. So the SLM implementation for chemical basically included their 7 process units. Part of the scope included implementing the or configuring the SIF, SRSs, interlock, and of course we did the SIF verification calculation. For the pilot test, we took 2 main units that have been piloting for the entire safety life cycle. We took those units also to pilot the operation maintain module. So, and that covered basically creating, which is part of the operation maintain module features, creating the field device, commission those field devices, also creating the testing groups for getting the proof test. So another customization that we did was regarding to the SIS valve overhauls. So I'm assuming that everybody here that work in maintenance, so especially during the turnaround, have a maintenance program. Part of the maintenance program during the turnaround is basically pull the SIS valves out and send those valves for overhaul. We identify an opportunity to improve the process that the refinery was doing. So we identified that there wasn't a formal criteria and work process to define how often you need to do overhaul to those critical valves. At that moment, that responsibility was under instrumentation, under the instrument group, but they were not really familiar with the process and the process safety and what each of those valves were basically protecting against and what part of a safety function was. And they really didn't have a criteria. We identified that during the turnaround, it was a large number of valves that the maintenance group was sending for overhauling. That was basically having an increase in the turnaround cost. So we saw as a team this as an opportunity to optimize and improve the process, and we got together and said, well, let's create a formal work process to define the overhaul frequency for those SIS critical valves. We define this work process based on criticality of the valve, information from the PHAs, valve service, and then we came with this formal work process. And then when we complete the formal work process, we say, well, we will be in the transition to moving or implementing the operation maintain module. Why we don't customize? Why we don't talk to Mangan to customize this work process into the operation maintain module? So we work together with Mangan, and they create a custom feature in the operation maintain module to basically follow the requirement that we have in the work process. So now we have the work process into the operation maintain module, and we can define the overhaul frequency, and also we are reporting the overhaul records of each of the SIS valve in the operation maintain module. That was, I said, optimization in the process, of course, that reduced the cost without sacrificing safety, and basically optimize. Now we have a formal work process. Again, it's on the SLM operation maintain module. Also, we did some customization with the FSA module. We were in the process. We conducted general SIS assessment. One of the gaps that we identified was that Motiva as a company were not doing formal FSA to projects. We recently had released a new engineering standard that have a mandatory requirement to conduct FSA 2 and FSA 3s. We say, well, since we have the FSA module, why we don't start basically conducting the FSAs using the tool? And we say, well, in order to do that, we need to basically customize the checklist available in the FSA module to be in alignment with the requirement of our corporate standard for SIS. I just wanted to show this. Who is familiar with the FSA module here? Who is using the FSA module? So I see Carolina. So I'm pretty sure that you are familiar with this work process. I just want to recommend you guys, so for those end users that are not using this module, so if you have a formal work process in your company, so I highly recommend to start evaluating this module, because this module facilitates the entire work process, because they already have predefined steps that basically make or facilitate the process to the FSA auditors. So in order to establish this as a formal tool for FSA, so I had to do customization. I work with these guys as well, with the SIS guys and also with Mark Gordon, to customize the checklist for the different stage or phases of the FSA. I shouldn't call stages. I know that the version coming for IEC 61511, I was told that it's not going to be called anymore a stage. So it's going to be just FSA 1, 2, 3, 4, and 5, just for your information. So any question regarding FSAs? Okay. Phase 5 started in 2025, and that basically covered the operation maintain implementation. So the scope of that basically covered creating and commissioning field devices for 66 process units. That included refining the chemical. So by creating the testing groups, so it enabled to track the proof testing status. So now by having those testing groups, so the system automatically start tracking when you have a proof test approaching. If you have past due, this is going to be shown into your metric that you have overdue proof test. That is one of the benefits. And also we set up a path for reporting SIS KPIs. That was the first step to start basically transitioning our SIS KPI, monthly KPIs to SLM. And Mish is going to be talking on more details during his presentation about it. So also part of this phase 5 included the SLM PI implementation and some pilots. For the SLM PI is our historian. So basically we did the integration. Mish is going to be talking in more detail about how that integration happens. And what we were looking for that integration was, well, we need to basically transition from manual tracking process to automated tracking process, especially for demand events and bypasses. We need to find a way to track those events in an automatic way, and that was probably one of the main drivers to integrate SLM with PI. So that effort is still ongoing. So there's still work to do, cleaning part of the database. But we already have the infrastructure set up. We are progressing in the process to make that transition to start reporting SIS KPIs in SLM on a monthly basis. We also start last year making some pilot tests to convert our cause and effect to SLM as part of our digital transformation effort. So right now we have a kind of we store storage our cause and effect metrics in a shared drive, and we have a lot of problem with the version control. Because of that, we decided to transition to SLM and have SLM as the master database for keeping the cause and effect into the instrument and system module. And we did some pilot tests last year. Also, we start basically working and doing some tests with the LOPA module functionality. Okay, to finalize, so this year, so we enter into the phase 6, which basically we are moving up now all the cause and effect. We are creating evergreen cause and effects in SLM for every single unit for the two sides, for the refining and the chemical. We start moving process units LOPA studies. So to answer your question, so now we are taking the LOPA that have been complete since 2021 under the new standards. So we are basically importing the LOPAs into the LOPA module, and we start basically linking. So the seal rated IPL credit in the LOPA into the safety instrument and function seal target into the, for all the SIFs. We continue cleaning up the SIF list. So as an outcome of this. So, and that was basically, it's the end of this presentation. Do you have any further questions? Yeah, the banker?
You guys have been implementing for quite some time now.
Yes.
Was there any, how did you integrate the plan changes into your existing database, like projects or installations?
All right. Yeah, that's a separate effort. So we also have for projects. So now we have a request that when they have each project that have functional safety in their scope, so they have to basically use SLM to basically have those set of deliverables. So we're using basically after the PHA is complete for the project, so we have a work process to take the result of those PHA. We use, in this case, we are using Felix now, and Felix is working with the project to develop a full set of SRSs, do the seal counts as well. We're doing the cause and effect in SLA and also linking, importing the LOPAS into the LOPA module. So we have a work process. So for project, we also are incorporating, ensuring that everything is going to go through SLM.
I was just curious if anyone had a better way, but I know this was 2 years ago when we were doing MOCs and had to make adjustments. We were having to record the MOC numbers in the comments section so that we knew why it was different than the main upload from the the 5-year HAZOP. But has anyone else had a better way to track changes made in the software? Because then there's always this deviation question on, okay, why is this specific calculation different than what's
Than the previous one.
the master PHA file from the 5-year HAZOP?
Yeah, I guess that Mitch can explain this better, but so for any change that we have on the complex, we have I can say that it's a robust MOC work process is not going through SLM MOC module. So since we already have a very robust MOC work process that basically we follow the existing MOC work process for that. And Mitch, I don't know, you want to add?
If there is a change like you're talking about, we actually run it through our PSM group for any kind of a modification to that PHA.
Right, but how do you track it in the SLM software?
I do not currently have a way of, I don't do it. I mean, there's places I'm sure you can, just not to that point yet.
Yeah.
We're trying to put it in the notes.
Gotcha.
Yeah.
And I was just curious where people were tracking the MOC changes from
I'd like to know that
5
too.
years.
I'd like to know that too.
Yeah.
Because that's the only place we knew where to try and keep track of it.
Sure.
There's a better place to
Yeah, that's a good
keep
question,
track
Emma.
of the revision history, because if I remember correctly, you can't pull up a revision history in SLM. It's only a current copy.
I don't know. You probably can answer. You can. Yeah. So, and you are able to see the difference, right? So between between previous revisions. So there is a way to do that. Yeah. So, any other question? Carolina. Pregúntame algo. Okay, guys, thank you. So now we have Mish coming with the next presentation.
The other ones?
Dean, how's that?
The online is a little too bright, so we're dimming it. So everybody standing here speaking is going to be dark. You can't see any of us. Yeah.
We can't see you anymore.
Yeah, we're gonna disappear. If you wanna,
Yeah, let's see how we got
you got a booming voice.
I do have a booming voice.
Double project, I guess.
Yeah, my wife would say I do not need this microphone. I promise you. I do on the sideline in my other job. I'm an announcer for a football team locally in the Golden Triangle area, so I do that kind of stuff. I did want to mention I see a few faces out there that I'm familiar with, especially from my old past Shell days. When we started talking about SIFPro, it was a funny story. If anybody remembers Art Waltman, he was kind of the mastermind behind it, and And I asked him one time, I said, well, where'd they come up with the name SIF Pro? He said it sounded much better than SIF Amateur. so there you go. Let's see.
Oh, let me pull that up. Sorry.
Okay, good deal. Thank you. No, you're good. They don't want me to wing it for the next 20 minutes
They
without
don't.
something to show you.
They don't, yeah. Sorry about that.
No, that's
Pull you
great.
up here. I think you're right here.
Fantastic. Thank you.
Hit the old present. And I think,
Yeah.
yeah.
Just hit the.
I think, yeah, arrow
Just
keys
move on.
probably,
Gotcha.
yeah.
Okay, good deal. All right, so what we're going to be talking about in this little session is basically it's going to be to add on to some of the stuff that Ramon had just kind of gone over as kind of our path as we've transitioned over into SLM. This one is near and dear to my heart because probably since I've been in this world probably now for shoot, it's been 15 years, I guess. Heck, longer than that, probably 20 years this year. So anyway, the trying to get accurate data on trips and bypassing is something that I think we all may have had struggles with at times to try to nail that down. And this gave us the ability to automate it. I will preface that with we are still trying to work through cleaning up a couple of the spots. ES Baldwin has been helping us out. We've worked with Mangan Software Solutions a lot with this to try to get everything kind of laid out and right. We in the past, way back in 2004 when we started messing with SIF Pro, we started to it was back in the day when you looked at economic factors as well for any kind of safety function. And so if you realize real quick that most everything fell under economics because hey, there's a dollar value there that you see immediately. And what we're finding now over time, of course, is that of the 3,000 SIFs that we say that we have in this huge refinery of ours, we've been working through this piece, and it's probably going to come down to, just guessing wise, somewhere around 1,500, 1,600 SIFs that we end up with. The others will be interlocks or operational interlocks. So that in itself is going to be a huge piece for us to be able to see, because we're trying to track these SIFs that have either failed or nuisances or, successful, of course. And so as we go into this, you kind of see how we transition this, and I've got a couple of slides to show you the finished product and what it looks like. So here, got of course, one of the important parts of maintaining improving process safety is to record leading and lagging indicators. We do this by tracking our SIS events, of course. Demands and bypasses is what we do. And report key performance indicators. Below is a list of KPIs that Motiva requires that we report monthly. So it's a pretty good list of things that we go through. So for our demands, we have, all being process safety demands. You either have successful nuisance or you have failures to trip on demand. Then we look at also our proof test tracking. Do we have any overdue tests? Do we have any active extensions that we need to monitor, make sure that we catch on either the next turnaround, or do we take this unit down to get those done? And also the bypass tracking. The number for Motiva, we're looking at that 72-hour something in bypass for 72 hours or longer than 72. That's the magic number for us. I know the chemical plant actually had it when we acquired them as being was it 24, Jerry, or 48? I'm sorry, it actually was more, right? That's right, 96 hours. So people may have a little different philosophy there as far as that goes, but ours is over 72 hours. and then the number of bypasses that we have in there per month. So that's kind of what we said. Okay, these are our KPIs that we need to track, and we're working toward that. So. So the ones that this is the pre-SLM, I guess I can call it SIFPRO now, but this is what we got from those, and we've basically focused on the trips, right? We focused on the successfuls, the nuisance, and the failures to trip, which is unsuccessful trips. And this was the part that really got me was, okay, we have an incident tracking database, and that incident tracking database is based off of, did the operator or the operator's supervisor put in that trip that they had the night before, and while they're trying to start that heater up that they just tripped, and did they trip it 3 or 4 times when they tried to start it up? Okay, and so you've got those numbers. Now they all can tell you a lot of stuff, right? You start a heater up and you fail to start it up, you trip while the pilots are lit, or you get going and you got a little too much fuel gas pressure and you trip off again. Well, that all tells you a little bit, I mean, you can tell you, do I have the proper startup procedures for this heater? Do I have an issue with any of the items that are taking place here? Is there a problem with with getting the pilot gas to the burner to actually light it? So there's lots of things that these things can tell you, and they all are events. So. And I knew we weren't getting all that data. I knew they weren't, putting in a separate ticket for every time something like this happened. But our Pi does capture those tags, and it captures them very well. We have what we call first out tags that will tell you what the initial trip was of something of an asset out there, and so we would take those, and so. The previous way of doing it, so I don't get ahead of myself, which I am, was to rely on operations to put the data into our tracking database. And then we would review each of the SIS events that they had put in there, tell it whether it's successful, nuisance, or unsuccessful. And then we would transfer that data to the almighty Excel spreadsheet. So I've got tons of Excel spreadsheets over the years that, I became pretty proficient at Excel spreadsheets over the years, trying to keep up with those things. And then that's how we did our KPI reporting. It was based off of that. And so with that, I don't know how well that you can see this. It's probably a little bit fuzzy, but this is what it looked like basically when we would come up with our monthly report to the powers that be at our refinery. It's not bad. I mean, it's got a lot of data there. But again, this data to me is skewed because it's only data that the operators chose to put into the system. We had no way of saying, okay, let's go grab what really took place from something other than somebody telling me that's the number of trips we had. So when we started to get ready to do this next phase, going into Pi, we knew that there were going to be a large number of trips, a big discrepancy. Okay, let's say on average I was having 15 trips a month. Okay, in this big refinery. I warned our technology manager. I said, don't be surprised to see 100. The numbers are going to be different because every first out that you get that's going to come up is going to be Pi's going to be triggering it, and you're going to get that. You're going to get that. So.
Also, for example, you got a trip, and they restart and trip again.
Exactly.
Restart and trip again. So they don't report this as just one trip, but the system is
looking at it and saying, hey, yeah, exactly. So it tells you a lot when you start to see this, and there's other things that you can capture. But this is when we decided, okay, we need to do something, and we discussed with Mangan what some potential fixes were, and that we heard that you could tie in Pi to this was like fantastic. Okay, this is what we need to do because I need to be able to see this data. So so the scope of the effort, this is what I wanted to go over. It integrates our Motiva Pi historian into the SLM cloud-based software. It pulls the SIS PI tags to SLM for automatic SIS demands and bypass event tracking. And it uses this data in SLM to report the required key performance indicators. Of course, there's many benefits. The real-time event tracking, that kind of speaks for itself, but continuous monitoring of the SIS system provides instant visibility into the system status. You've got early detection of issues. So if you're starting to have an issue with deviations or anything, you start to see those. You can see that those issues right up front. I don't have a slide on here, but I was doing the February metrics, and we had a trip on one of our heaters, and it's kind of like Ramon just pointed out to. You saw within about a 40-minute period that unit or the heater tripped 3 times. So I knew they were in the process. Okay, they tripped, and they're in the process of starting back up. You could just just how it was going. You can track that. Your improved safety performance that comes into play, of course. Your automatic tracking facilitates comprehensive data collection on SIS events, which can be used to analyze the system performance, identify trends, and implement corrective actions, ultimately enhancing your overall safety performance. And then, of course, you've got your compliance. You're going to be filling out your KPIs with this. That's very important to be able to monitor that. Efficient with troubleshooting. If you have someone that's one of your E&I techs going out there to go take a look at it, immediately that from your first out that, okay, you had this issue. Let's start back from there and figure out what the issue was. It's nice to have that really quickly to be able to see that. And then, of course, you got your risk mitigation. That automatic tracking enables protective risk management by enabling organizations to identify and address potential safety hazards of vulnerabilities in the SIS before they escalate into serious incidents. So this next slide, I'm not even going to pretend that I even know how this networking works, because I am not a network guy. I do know this. This is Motiva's environment, and this is the SLM environment, and this little guy, the SLM CGI, that is the kicker right there. With Motiva, we've had some go-arounds and run-arounds and thus and such with this one. Typically, if I'm not mistaken, somebody correct me with MSS if I'm wrong about this, but typically the SLM CGI sits in the SLM environment, typically, but not if you're Motiva. For whatever reason, okay, Motiva wanted to have control of that. Okay, so we put that CGI on our side.
I think that is because of their cybersecurity.
It is.
Requirement. They said no, so we had to right now basically link Mangan to both these.
I'm making light of it a little bit, but that is definitely the reason that we did it.
Cybersecurity, their policy that the IT has.
Yes.
They said no, so we had to host it.
And so, with that, you're relying, if you need to troubleshoot that, if there's an issue, most of the time, our folks need the help from SLM, right? Or from Mangan to help troubleshoot that. So they've got to have passwords to go into our system and to be able to go in and fix it. But however you end up, working through it. Is that Stephen back there? Did you sneak in over here? Stephen's the mastermind for us on this right here. All right, Stephen, is there anything you want to add to that as far as Yes.
So I think for clarification, so PI is pushing the data to CGI?
No, I'm pulling from your Pi Web API.
Okay.
And then I format it and send it to our API. Basically, a little middleman in the middleware that does all that.
Okay.
And if you guys have any other questions regarding that, we've got the guys that can talk to you about it through it if you're interested in doing this. But it's been very helpful for us, that's for sure. So this is what basically some of our slides look like based off of, you're basically looking at your successful, your nuisance, your failure to trip and this is from one of our months there that we popped this in. So, had a couple of nuisance. We did have one failure to trip. So you immediately go out there and start tracking, trying to find out what happened in this situation. That's the number one priority in that slide right there. So, it throws that up there for you. They've got some user-defined type of graphs, charts that you can use. That a lot of this stuff was already built in the system. We did ask for a couple of different niceties that we do, like an executive summary that gave us the ability to be able to write in some stuff and things that happened. Just a real quick, paragraph of what the SIS system looks like for the past month. We can put that in, send it out on a web view to our different customers and let them see what's going on and how the health of the system's going.
Yeah, and to add what Mitch is saying, so we part of our former work process standard requirement for operation maintain. So we have some requirement to investigate demand, and especially the failure to trip on demand required to do a root cause analysis investigation of all that report. That's
Yes.
our work process.
Yes.
But let me ask this, as a former process engineer and process safety guy, how are you figuring out failure to trip on demand? Because that is massively difficult to do. I mean, I've had fires on my offshore platform and the stem breaks on an emergency shutdown valve, and there's no instrumented PI system that tells me the stem on the valve snapped, right? And so I'm just curious how deep you go into programming, the failure to trip on demand. Are you still largely relying on operations to report those?
No, you can. Well, the way I look at it is this: if you have a trip, you're going to get we're going to get our first out tag. I would assume most everybody has something that says, hey, there's something out there that says I should have tripped. Okay, here's the system. All right, and in your case, if you do have a final element that does not go to its safe state, okay, you're going to pretty quick know that it didn't go to its safe state. I mean, that's what we're looking at, right? We're taking it and saying, okay, and we've got plenty of data that's on our DCS. We can go out there and actually look, but we have it on the DCS a lot of feedback, right? If my valve doesn't go to its close or to its most of the time close, right, safe state, then we can know about it pretty quick if that happened or not, or how long did it take to get to that state, right? I mean, that's some of the stuff that we have programmed into our not only our Tricon but into the DCS system, to get feedback for that. So we can know pretty quick on that. Maybe a little different on a platform, but it's still all basically the same. It's going to my final element. Did it work or not? Right? That's going to tell you if you had a failure to trip or not. I mean, that's a big part of it too. Is the process safety time.
So process safety time versus your system response time. So we have some of the custom code in our logic solver that basically track the valve, for example, final element times closure. We can compare against process safety time to ensure that your response time is faster than your
the process safety time.
And I agree.
Yeah.
New fancy facilities have extra position switches. You gotta realize there's frontier locations, there's old janky places.
Yeah.
There's a lot of places where you do not have, confirmed open, confirmed closed switches.
Yeah. Yeah.
And there's a lot of space in between to try and determine that.
I could see that would be that would be a difficult deal. I'm definitely talking from a viewpoint of, well, we used to be there, right? We didn't have that stuff, and we realized it was a need for it. So we started with our SIS, to say, let's make sure we have feedback on those valves, to do that. But you're right, there's going to be that gap. Yes. Yes. That you're right. If we have an input that does not read, yeah, you've got to. And I don't know if you guys. Well. So do you have
Those are the cases where you basically have failure dangers undetected.
yes.
So those are basically when you have your failure rate, those are the numbers that you use on your
Yeah, because
system
it didn't
operation.
work.
You use your dangers undetected failure rate.
Right. Well, the only way that we do it is we have deviation alarms between a DCS transmitter and our SIS transmitter. And that's really kind of our, I guess, tattletale. If we have an issue, I think we set ours typically at 10% is basically what, a 10% deviation. And that's how we see that.
Yeah, remember the event that we had like a couple of years ago where
Oh, yes.
so they have a special calibration on some level 2 meters. They did the calibration check. There was a miscommunication. They did better than me. They recalibrated it.
Mm-hmm.
The transmitters and the transmitter didn't detect. It was a low level or high level.
I think it was a low.
It was a low level that it wasn't detected by the SIS transmitter, but the DCS transmitter was looking at low level. So that one was an undetected, that was undetected
Yes.
failure. So.
Do you have something?
But to be clear, I mean, all of the success or failure, whether it was a nuisance trip, all that's still entered in after the event happened.
Oh, it is. It absolutely is.
Obviously, it gets triggers and say we had an event.
That's right.
Build the data on that event.
You still.
Yes.
Correct.
You'd have to just build a new event and say, hey, we had an event where input failed.
That's right.
It just wouldn't be an event that was automatically created through this interface.
You're exactly right. All we're doing is capturing events. You still got to tell it, hey.
This is still dependent on someone manually entering all the results and whether it passed, whether it was successful, did it meet PFT, all those things.
Yes.
Still manually entered.
The good thing about it is and thank you for that. You're right. You're exactly right. The good thing about it is once it gets to this point, once it gets to those tags, it's someone who typically knows a little bit more about SIS than if you're asking an operator to go and just fill out this form, right? I've got this data. We got guys that are working with me that, hey, we'll go in, we'll look at it daily just to see if we've had any kind of events, and we keep it cleared out that way and say, okay, that's how we do it. But you're exactly right. You still got to enter some data.
And the operation maintain both already have a pre-populated work process that facilitates. So yeah, you go through the investigation, you capture the event. You went to the through the investigation. Once you realize whether it was a successful nuisance trip or failure demand.
Mm-hmm.
So you go to the system and the pre-populated system already have. So I think that we need some customization to basically define what type of trees we have. We go through the work process in operation maintain and basically we'll report this, and once we report this, go automatically to the multi-metrics.
Yeah. So yes.
So you talked about having a person do that already.
Right.
I think I've been doing this. The biggest problem we've had was to get the blue, right?
Yeah, the nuisance. Mm-hmm.
You need someone from operations.
Oh, you do. Yeah. Very, very helpful to do it. Yeah. Yeah. We've got, I've been trying to work with our control system engineers. We have, one for each of our areas, it's, again, a big place, but trying to get them familiarized with, okay, what is a nuisance trip? Let's define that. Let's talk about this and how this goes about, again, a lot of it is learning. It's a learning type deal as you go through. You can look at some things and go, yeah, obviously I had a failure on a control valve that that caused this issue to happen. But it's whenever you truly have a nuisance trip, that's a nuisance of an SIS component, right? I mean, if I have a nuisance trip, if I have a trip and it was my control valve, that goes down as a successful trip for us, right? Because so if you have that, okay, how do I see that failure in that piece of the SIS architecture? Yes.
One, I would like to add another category which we come across with tests.
A test?
You have online tests. Systems activate.
Yes. And right, you're very good point. And they actually have that in SLM. That's one of the things you can go. You were doing a test and it either failed or it's a partial. Sometimes maybe one of your valves closes, the other one doesn't. Okay, there you go. It successfully did it, but it had a failure on it. So we have those things in there as well. Yes, sir.
How many flags do you have built? And then second part of the question, were they able to link directly to the existing logic shutdown flag, or did you have to modify the logic to make it a slim flag?
No, it absolutely would. It comes straight from our Tricon basically. We have a first out for every SIF trip that we have in each of our systems, and so I mean right now it's probably close to 3,000 tags that we have set up in there. Now that number is going to go down, like I said earlier. You know, we're clearing out right now to know what is an interlock and what is a SIF function, right? But yeah, it does it straight from these tags. Yeah, these tags come out, they go to our DCS, and then when it gets to the DCS, that's where Pi grabs it. Pi grabs it from there and then sends it over to that SLM data. Anybody else? I'm going to move to the next slide real quick. I know I'm a little behind on my presentation. I'm gonna blame it on Ramon. All right, so this is another kind of step. I like the slide. I like what SLM can do for us right here. As you can see, the demands per equipment type, kind of nice to have, right? I mean, if you go down there and as you do and fill out all your SIF functions, you know, well, it's a heater, it's a compressor, it's a pump, vessel of some sort. You can tie those in, and what we've done is basically have them broken down into the boiler, incinerator, thermal oxidizer. You have a compressor, blower, heaters, pump, power, vessel. Okay. The other piece is the demands per contributing factor. Now, this was a list that we've been fighting over. Probably Scott Abraham probably remembers a few of these contributing factor things that they look familiar. I took them from what I used at Shell, and then we kind of modified them a little bit we've added to them. But there is always the dreaded other. Okay.
Other.
Too many things fall into that, but that's sometimes, that's just kind of what it is. But you start to realize, we started finding out like on one of our units, one of our areas, our hydro processing area, pump switches. Pump switches were just ridiculously coming up so much on these successful trips that we had because it would starve, the other pump. I thought, are they stopping a pump and starting the other one up? How are they missing this, right? So, and in some cases, their operating procedure was wrong. It was messed up, and they were following that. And we kept getting, they could start the pump back up, but I'm getting that first out now that I had an issue. And now we kind of looked at it and said, hey guys, let's fix this operating procedure because it's not exactly right. Some of them were other issues besides that. But
it's causing a lot of heater trips.
Yes, exactly. Yeah. And so you got SIF component failure, non-SIF component failure, kind of like we talked about the control valve a while ago. Hey, it's non-SIF, but definitely if you have a control valve issue, you could very well be tripping the system.
You have to add the issue that we have with heaters in the past.
Yes.
So especially on the flow passes that
yes.
we especially
yes.
rain events.
Yes. We had very long lead lines that would take us down. Now, yeah, that was a real issue. The ones that our operators don't really care for me to have on there is operating too close to the set point. That's there really to help us to be able to find out, to identify and define the road that you're on, right? Am I going down into the ditch? Should I make that road a little narrower? Should I widen it out? What can I do with this, right? I mean, for half of our plant, we've been around a very long time, since 1903. But the newest part of the plant's been around for 12 years, okay? And they're still tweaking to know how that feels, how are these trips set up and good. We've got them pretty much nailed down, but every now and then you come up on you keep bumping up against a set point. You're wondering, okay, well, do a little debottlenecking or something like that, and you realize, oh golly, I gotta adjust this range and make some adjustments. So we have that on there for that purpose. Abnormal condition to unit. Sometimes, every now and then in Southeast Texas, you have a little freeze comes through. You have a hurricane that might come through, right? Of course, startup of units, that usually falls into that as well because you're in a startup condition, okay? Or you're shutting down, you're getting ready to shut down. those kind of things. And then we also added a manually initiated trip too, because that was one that, okay, we knew they were coming down with it, but I couldn't capture it before. Now I have the ability to say, okay, yeah, they actually knew that they were coming down with this system. They hit the stop button, or they control stop this thing. And then we've had loss of power before. That creates a lot of issues. But that's kind of what it looks like right there as far as that goes. This one is, sorry about it's elongated, kind of a little messed up, but this is our bypasses. We have an online bypass form at Motiva that basically keeps up with all of our bypasses, when they're in bypass, when they're out of bypass. So it wasn't so much needing to see that data, and knowing when something was in and out of bypass, but this gives you that monthly look. It gives you how many of them actually were over a 72-hour period. Really quick, like you can just look on the same data as, that you're looking at for your trips. It's all right there. It's all your KPIs just go into one spot. It's beautiful. And this one here is your overdue tests as opposed to your scheduled, okay? And we had one overdue test because we were doing the turnaround in January and February, and it just hadn't gone in there we just started the unit back up. So when I did the slide, that's no longer, it came up as overdue because it went past the due date while we were in turnaround. So, and once I do that, it'll be cleared out. But the scheduled events, it shows up, a lot of times, what does a slide really tell you? What does a graph tell you if everything is green, or if everything is red?
Green circle.
Yeah, it's just a big green circle, right? Exactly.
Nice job, guys. Green circle.
Exactly. Yeah. Well, but anyway, that's just another little piece to what it can do for you. Yes.
Just to add, on the previous slide,
Uh-huh.
so that we leave it for that was a customization. The previous one, that was a customization that was part of this implementation.
Oh, yeah.
We customized, we requested to customize our dashboard.
Yes.
Because that wasn't the default dashboard that Mangan had.
Yes, and so yeah, it's been a really nice little run, little journey with us.
Have you been able to find a good way to track overrides of startup interlocks, especially on third-party units? I mean, one of the worst actors that I typically see is compressor packages.
Yeah.
You have, a 15-set startup sequence, and operators know, oh, well, it gets stuck on 7. I'm going to just disable a little step 7 pressure interlock or whatever. And those we don't normally have enough comm channels from the from the third-party unit back to our PLC or DCS to track everything. And I was just curious if you guys had a good way to monitor those startup interlock skips by operations.
Can you think of
We have a bypass for every one of the initiators.
We definitely do, and so it sounds like with their third party, it's hard to do that because they don't have that ability. They don't have enough.
We didn't program it.
Right, you didn't program, yeah. Yeah.
Sort of
The only ones that we typically have, which it doesn't affect us much, is because they're mostly like either an Allen Bradley, non-SIS PLC that they bring in on a skid package of some sort, that we don't have any SIS until, all those types of packages. Yeah, right. Yeah, but we just have bypasses on all of our stuff. Yeah, so I don't have. Maybe somebody else in the room might have that ability to answer that. But I am done with my presentation. Anybody else have any questions? Yes, sir.
Yeah, I'm just wondering if you can create more scenarios where the SLM integration actually improves safety performance.
Well, to me, this and the reason I had that on the slide is because it tells you every time you've had a safety issue. Okay, if you have a first out, if you have a tag that comes up on any type of a system, if I can only speak from my past experience. Okay, so when I'm dealing with manual, someone entering this data manually telling me I had a trip, as opposed to this automatically coming in and having 4 trips in a 1-hour period, that's a lot different than just saying I had one incident to me. And to me, that improved, by knowing that, you can improve your safety by going and fixing whatever that issue is that caused them to trip that multiple times, either during startup or where they have, were they bumping up against a set point that is too not set up correctly. That's where that's why I had that bullet there. That's what it would be.
That automatic tracking also allowing you to identify potential bad actors. Because
Yes.
So you start tracking and you realize that you have multiple trips in the same equipment, but with the manual process, it records just one. But then you start realizing that you have multiple events on the same equipment. You can say, okay, this is a potential bad actor, and then you say, well, we gotta start doing a kind of a root cause analysis to identify why this equipment is having so many events. So once you can identify the potential root cause and take an action to basically correct those. So that's basically another help by having this automatic tracking system because you will be tracking every single event.
Mm-hmm.
And part of the operate and maintain module, mean time between failures,
Yeah.
goes into your seal count.
Yeah, it does.
So you have any more demands.
Yeah, you'll start having a continuous demand. Yeah. Yeah. Yes, sir.
Do you ever take your demands and use that as a credit for your testing?
I have not. We've talked about doing that multiple times because we're not there yet.
We are not planning. What we do is basically we have our proof test schedule on turnaround. So
Yeah,
we are not trying to skip those.
We're that far out with all of our SIS. Is basically it's 6-year turnaround intervals is basically where we're at. But that's a good question. I was trying to do that when we were still with CIFPRO, and I was like, man, because I had several that were 3-year or 2-year, and it's like, oh golly, if I could just take credit. But I couldn't at that time. I couldn't prove it because I didn't have all the data that showed that I had my final elements that tripped off and did everything they were supposed to do.
Yeah, you go to the mechanical integrity ISA for technical report. They say you could take credit, but you have to meet
a list of criteria.
Requirements.
Yeah.
So, and you're gonna have everything. That's a big list.
Yeah.
On that technical report, you gotta be very careful with taking credit for that.
But I've done it before. I mean, especially the easiest one is like the easiest one to take credit for is like your emergency flow down system valves because there's a big investigation regardless.
Absolutely, it's happening.
There's so much instrumentation around those.
Yeah.
If your emergency depressurization,
You're going to have the data from that. Yeah.
Have all the data.
That's a good point. Yeah. Good point.
Those only happen typically every 3-4 years.
Let's hope. Yeah.
But,
yeah.
Typically when we have those, we can retroactively.
No, that's a good point too.
To get all the information on the emergency depressurization.
Good point. Anybody else have anything? Well, thank you guys very much. Appreciate it.
What we're going to try and attempt to do here is bring in Marco Turdo from HEMA. He's going to be. I'm going to dim these a little bit. Did you guys want me to dim these back ones as well? Or are you okay? I think they were trying to do the online was needing a little bit of a light level back out. So let's see. Hey Matt, were you able to get him to join in? See if he's going to join in on Teams. Right. All right.
Okay, guys, can you hear you?
Okay, hold on a second, Marco. We're gonna
Yes.
try and put the audio through. Go ahead and talk a little bit.
Yeah, can you hear me?
Yeah, I can hear you. Let us hope that.
Good.
See here, we're just getting the audio dialed in here. All right. All right, give us a sound check.
Yeah, okay.
Keep going.
Good morning, everyone.
You guys hear?
Does that work?
No, it's here. This is the microphone. Trying to see where your speakers are. I guess it's supposed to come out through those speakers, but it doesn't. Go ahead and talk. Go ahead and talk a little bit.
Yeah, so I hope you are able to fix the mic problem. Can you hear me now?
Yeah, keep going.
Okay, can you hear me?
I think it comes out from the front here. Go. Keep going.
Once more, Marco. There you go.
Perfect. We can hear you.
Can you hear me now?
Yes, we can hear you. Thank you.
Okay,
Let's
perfect.
reduce this. I forget how.
What?
Reduce it, like make it big.
Oh, okay. We'll go full screen with him. I don't know. Oh, maybe it's view.
Speaker only.
Speaker only. All right.
Close the chat.
Nope.
Nope.
You're fine. That's okay.
All right.
All right. We're good. Go for it.
Okay, perfect. Then thanks a lot.
All right. Go ahead. Thank you.
Go ahead and
Okay,
share your screen whenever you're ready.
Yeah, you can
Marco.
share your screen wherever
Yeah.
you're ready.
Perfect. Yes, thanks. Sorry for this additional work I gave you today for setting now everything for a remote connection. I'm sorry not being able to join you. By the way, my colleagues from EMA Americas are in presence, so you will find someone from EMA today. Let me start to share my screen, and just let me know if you can see what I'm presenting.
Yes, sir.
Can
Go
you see
for
my
it.
screen?
Yes.
Yeah, can you see it?
Yep.
Perfect. Okay. So thanks for this opportunity to speak today during the SLM User Group event. I think I can stop my camera in any case. It's not essential right now. In the next hour, so I will structure the discussion, the presentation in 45 minutes of presentation and allowing 10-15 minutes at the end for the question from the audience. The topic of today that Iman is bringing to the SLM User Group event is the digital functional safety integration. So we will explore a bit in these 45 minutes how HEMA leveraged the use and the partnership with Mangan and SLM to come up with integration solution for digitalization of the life cycle and digitalization for functional safety. So before jumping on the technical content, allow me just to introduce quickly myself. My name is Marco Turto. I work for HEMA Group since 1 year now, and I'm the global lead consultant digital safety. Before joining HEMA, I have been the head of global functional safety at Covestro, so chemical end user, chemical producer. And before that, I spent almost 14 years working for engineering contractors with different roles and different countries in Europe, in Italy, in France, and Germany. Just quick overview on the agenda. I will introduce the concept of HEMA safety lifecycle digitalization that is using the integration concept. And then we will pick up two use cases that have been selected for you today, automated proof testing and SIP performance analysis. And then there will be just one slide for wrap up and conclusion. I didn't put much about marketing slides, honestly, related to HEMA, but I will just use this one to clarify a bit who is HEMA. Probably not everyone in the audience knows HEMA as a company. So HEMA is a technology company that is focusing on products and solutions for safety related automation. We are specialized in functional safety area in the domain of functional safety. You know, the title of this slide is functional safety is our DNA, because we started early last century, and I would say we have already some years of experience, and we have been pioneering functional safety in several ways. For instance, we have been the first in the world to get safety hardware controller that was certified by TOE. And later on in the 80s, we have been the first to have a TOE certified programmable logic solver for safety-related applications. So we have this kind of story of being the first of doing pioneering activities in functional safety. And functional safety is our DNA because from the products itself, then we expand into application services, consulting solutions. So we now have a worldwide organization. Our installed basis in terms of systems is around 50,000. But as I said, we have now different departments that can cover additional activities. We are about 1,000 in the world. And you can see in this slide the main differentiator between EMA and competitors that we only talk about functional safety. We only talk about safety-related automation and safety-related solutions, and competitors are usually having a bigger portfolio, so that part is only one area of their portfolio and their products and solutions. These allow us to concentrate on this topic, on functional safety. These allow us to invest internally in research and development and to start an innovative campaign. The last campaign that, of course, is related to digitalization is named Safety Goes Digital. This was launched end of 2022 by our top management. And this is not only a campaign, but this is the vision of EMA for these years, for the upcoming years. And the target of this vision is to digitalize functional safety, maintaining added value for customers. And this is founded on 4 pillars: safety and security. So of course, you know, there is no safety without security. Enduring compliance, making sure through digitalization and right usage of data, we can get to compliant plans and systems and maintain this compliance over the operation, which is, I would say, the critical step that a lot of companies in the process industry is struggling with. Streamline engineering using digitalization and functional safety for reducing workload, reducing complexity in the engineering steps, especially when that comes with the design, hardware and software specification and realization of safety systems. And effective management of change that is starting with identifying that nothing is changed. Again, so that analysis verifying that everything is as per required and there is no unexpected change, and then having systems for dealing easily with changes. Let's then start the core of this slide deck, introducing the HEMA Safety Lifecycle Digitalization concept. As I said at the beginning, this concept is centered on the principle of integration. Digitalization through integration. So this means focusing on specific area in the process industry, creating solutions that are oriented for customers' needs that can tackle issues or I would say even enable new opportunities for customers. And in order to work on integration of such kind of digital functional safety solution requires certain parameters, it requires certain characteristics to be there. So first of all, a strong know-how in the process industry. As I told you, this is the case. You need to know the process industry, you need to know the arena in which you need to play, you need to have close contact with customers, and you need to have expertise in functional safety lifecycle activities, which is not confined between the cabinet area, so what's happening inside the logic solver, which is, at the end of the day, the safest piece of the entire loop and the piece that doesn't really expose too much to issues usually, but having an understanding on the entire life cycle from the beginning to the end and from field to control room, even to organizational aspects. Strong know-how in technologies. So integration means taking different solutions, hardware, software, tools, integrating them to create something that is offering new added value. That therefore know-how in technologies is important, and expertise in delivering applications-based solutions so that we can combine different aspects to create a tailored application. Strong partnership, this is key, and this is also, I would say, one of the reasons I'm also attending this SLM user forum, because we have, I would say, a dual, ambivalent relationship with Mangan. We use SLM, of course, so I can also share later on something about usage of it, but we have partnership that with Mangan that allows us to work out this integration concept. Of course, last point is active consulting using the digital solution shell happen so that the integrated solution is really lived up by the company that is structuring this solution. And all of these points now are part of the integration concept and are fulfilled. All these aspects are characteristics of IMA so that we are well placed to play a role now in this new integration of digital solution for functional safety. Now we enter a bit more in the technical aspects. So what's behind this concept? What are you integrating, guys? This is the question. And I will show you different levels that can be seen as also a specific portion and parts of the solution. And the starting point is SLM. SLM, as you see on the left, is the foundation level. This means that we use SLM to create the so-called single source of truth, to create a basement for the concept itself, for the integration itself, and the main repository of information. And using as well the analytics that are embedded in SLM, this creates, this gives to SLM the role of foundation level. I go through quickly in this slide, and then I spend some more time for every layer. Let's put it this way. Around that, since we are user of SLM as well, we are creating our own standards in terms of libraries, templates, adjusting settings. We, in order that we can work as we like in SLM, SLM likely give us a lot of opportunities for adjusting the way we want to work with it. And since the integration concept is also based on putting together parts, we need to have something around SLM layer to connect other worlds, to connect other data sources and other systems. And then we developed an additional layer around SLM called Easy Operation that has two main functionalities from usability point of view. In this layer, you see here the label IMA dashboards. We developed dashboards that can support customers in active monitoring of compliance. We will see some example later, and active monitoring of processes. And on the other end is also supporting customers in the creation of digital workflows. When I say digital workflow, I mean a complete process from the beginning to the end in a kind of closed loop of data flow. This means that this level is also used as a data bridge to other additional systems. In this case, you can see in the last level of Digital Plus, in the best case, when we can have a full integration to get the full benefits from this solution, then the integration layer is connecting our platform, so our safety systems and our engineering tool, in order to create a complete data flow without any interruptions, that we are able to create digital workflows. And we will see an example in the use case. Connecting parts doesn't mean only putting together hardware, software, tools, or technology, but also is going through services. So data infrastructure and OT security, because we are also experts in OT security, and we, of course, have to deliver something that is secure, training, and consulting. And all of them can be seen as a layer, but can be also break down in parts. So this allows us, if we think in parts or pieces, to create application-specific solution for customers so that we are able to compose the puzzle to fit into the need of customers in a modular, scalable, and flexible way, so that we can span from, as I say, application-specific that can be tailored till the complete FSM digital transformation. We find this, of course, this strategy quite convenient because there is the need to start simple in many cases. There are the need to focus with customers on things that can bring added value in a shorter time possible. And this means tackling pain points, or as I said, creating opportunities. Because based on my experience now, digitalization is really giving us the opportunity to say functional safety is no longer a burden, but digitalizing it in the correct way can also open up of, I would say, opportunities for improving productivity and reducing costs. Now, let's go through the different layers. I will spend some work on the different one. Of course, let's start with the foundation level. I don't need to spend too much time in describing SLM in the details, but I would like more to share now our experience in terms of which are, for instance, the models that we see more demanded, more requested, that we even internally use more. And of course, at the moment, I can share that the two more used or requested models are the instrumentation system and operation and maintenance. And I would like to share with the audience why we selected SLM and Mangan for this partnership. So the integration idea is that also you have your own tools, you have your own development, and then you search in the market what is best for you to create what you have in mind. And I think SLM was really the right fit for our idea, because this is, as I said, a really complete engineering tool for functional safety. There is nothing missing. It's the only one TÜV certified. Already at this level, there is possibility for connecting other systems. And what I like is that it guides the users to compliance with IEC 61511. And as I mentioned, I have been the head of global functional safety for a chemical company, and I have used to write thousands of pages of standards. And you know, the effectiveness of that is not that high sometimes. And having trained personnel that can work in an environment that support the compliance already, that really limit the efforts in creation of standards, templates, guidelines, and all of that. Of course, what I also really like and valued so far is the embedded analytics that are in the operation and maintenance module, that are the ones that needed for creating performance evaluation. And of course, since we are using SLM on the foundation of our integrated solution, the open data exchange through API is also a key characteristic for us. Let's move on the second layer that I mentioned previously, so the easy operation level. What's that? Now, this is, you can see a bit more now, we are talking about dashboards. We are talking about graphics. I think a good example of explaining that is you could imagine that this is the cockpit for functional safety management. So it's an easy way to look at key information, visualize them for people that are not functional safety, are not coming from this world, are not trained, and nevertheless helping them to monitor compliance, to monitor the realization of key processes, and help them to, we say, react when needed to avoid non-compliance issues to become something worse. So the idea of these dashboards is to extract data from SLM and other data sources. So you have seen in the main intro page where the puzzle pieces, the best case is when we can integrate, for instance, our platform with SLM through this layer, and then having combined all this information at this point. But of course, when we come for process monitoring and monitoring of compliance, then the same set of information can be sourced by historian, for instance, so it's not linked to having a HEMA system. The HEMA system will be required when we discuss later on active digital workflow, when the HEMA logic solver will also play a role. But for monitoring functionalities, you can imagine that we take data from the connected systems and we elaborate this data, and we have a different cut on this data, presenting them in a way that based on our experience in the process industry, based on the experience from people like me coming from end users, can make sense for production team. So this is a bridge to production team. This is the target group of this dashboard is the guys in the units I experienced a lot of resistance in the past, in my previous jobs, introducing tools, introducing trainings, introducing something new, because these guys are running 200% of workload. They are overloaded, they have a lot of things, and my idea was, okay, but what are they used to look at to monitor and manage their plans? They are used to look at HMI. They are used to react to alarm and alerts. Let's try to make something similar, but for monitoring and managing compliance with functional safety. And then you see that the system is embedding trends. For instance, if you need to monitor processes, you will see later on a couple of examples. Is including alerts and alarms. So SLM is having all the information related to what is not okay, what is okay, and based also on additional checks we do on live data, we can already bring this to the surface and notifying, okay, you have a non-compliance here, you have a problem there, so that we can focus the attention of the production team, which is also responsible for the safety of their plants, on what is needed to be acted. You see, this is the style a bit from the main dashboard where there are key KPIs. It's a dashboard with number of apps. I will go through the different apps developed in the next slide. And because this is a high-level type of information, you always will need to enter SLM later on for additional investigation, additional analysis. But at that point in time, the person in the production unit may already ask the support from an FS engineer or an expert in their company or an expert outside their company. So this is also suggesting a bit the competency of management inside an organization. Let's move on, and I will go quickly through the dashboards that we developed. The first is prior use monitoring.
Hey, Marco, we did have a question.
Hey, Marco, can you go back to the previous slide?
Can you go back to the previous slide?
Yes, of course.
So trying to understand the workflow, I'm assuming that the first step is basically design, so major conceptual design into the SLM instrument system, basically to create, configure your safety function, interlock, etc. And then I guess that the HEMA logic solver extract that data into their system. And then, you configure your logic solver, and those dashboards that you are showing are in the HEMA system.
Yeah,
No, this is a SCADA system.
Oh, this is a SCADA system.
Yeah. So this is a SCADA system that is then taking information from SLM and from our logic solver or an historian. And there are logics embedded in this SCADA that are comparing live data with design data and in SLM. So as I say, this is a support more for operational teams because of course we consider that the design is already available in SLM and we have all the design criteria and the performance elaborated by SLM. And then we extract this information, we compare with the information of live data. And another thing that I forgot to mention is that by reading information from a live system, we are able to create events that can be synchronized then in SLM. So what does it mean? We can read variables like the status of the valves, like the trip point as being reached, and then we can decide based on the right combination in the logic in this SCADA level that maybe is a successful trip, or is a spurious trip, or is a trip with a failure. So these events are pre-created in the dashboard level and can be synchronized automatically or manually by the operational team into SLM. So then in SLM, when they arrive, they already have a number of new information to make the internal validation of the event faster. Because you don't need to go back and talk to the operators or look in the historian, okay, what's happening here exactly. This is already done, and then there is a benefit in making a bit the workflow of code faster.
Okay, yeah, I think that answers my question. So basically, the first step is extract data from SLA into your let's say SCADA system, and then from your SCADA system you feedback data into SLA operation and the module for the management. Okay, thanks.
Perfect. Thanks. Let's see now, as I said, the applications that we develop. The prior use monitoring is the first. As I said, we use dashboard for monitoring processes. In SLM, we find all the data about prior use in service and all the key information that are generated through the analytics. And then we extract them and we support the process of declaration for prior use monitoring for customers. So you know prior use monitoring, if you use, for instance, NAMUR procedures or internal procedures of customers, you need to reach certain amount of hours before you can declare a device as prior use. But this is not a one-time activity. And so unfortunately also I experienced that. You make the declaration done, finished. Fortunately, it's not like that because you need to maintain this declaration over the time. And true, you see here now it's just small because I cannot spend too much time on every of them, but we create some trending system and some automatic analysis that is looking if the performance of one generic model is decreasing, and then notifying, now you have a problem, the performance of this generic model is worsening. Or during the process of qualification, if you get a failure, then you are notified, your declaration maybe you need to avoid that, or making additional investigation. So this is the idea of supporting during a process with visualization and easy graphics. The second is the SIP gap analysis. Now let's imagine that we have all our generic model have so much hours of operation that we can generate our own failure rates. in this SIF gap analysis, we will know that all the devices that are used in a SIF have this kind of status, or they have their own failure rates, and this is approved as operational hours because there are enough operational hours. And then you can switch your calculation type from design basis in SLM to prior use basis. This means that at this point in time, your PFD is not static anymore. It's dynamic. It's changing continuously based on the failure rates. Therefore, the need of a monitoring system that will tell you if you are approaching the seed band limit, if you are going over it, and how to react. In this view, the user will also get information about monitoring of parameters that are influencing the PFD calculation itself, so that we are no longer able to meet the risk reduction factor. This is why it's gap analysis in this case. One example, we monitor that in the formula we specify proof test interval 3 years. We monitor that in the proof test group, the 3 years is specified and is not 4 or 5. So this kind of alignment between them. SIF performance monitoring is instead per SIF focusing on all the main characteristics and parameters that can tell us about the health of a SIF during operation. Of course, here we use also data that are coming from SLM, plus data that we can log from our system or historian. And in the back of this dashboard, there is the event creation, as I explained to you. We have now 5 defined as a starting pack, 5 type of events. Trip, spurious trip, failed trip, detected device failure, bypass events, stuff like that. These are pre-logged in the system, and then the user can automatically or manually synchronize in SLM for, say, the final validation. Last is the automated proof testing. I will mention something more later because it's part of the use case I picked up. And this is actually a graphic that is in between SLM and our logic solver that support the user to manage the proof test in an automatic way, from the notification till its execution and failure data management. Of course, all of them has some portion that is sharing data. They are all connected, these dashboards. And we have in the pipeline also new ideas with additional dashboard. All of them are available for any type of system, so you don't need to have HEMA system. Only the automatic proof testing needs to have our logic solver, and I explain you why later on. The last part of the concept is the digital plus level, which is our system. So as I said, there are different level of benefits you can get depending how many of these layers you can integrate. When you can integrate HEMA systems, then you get I would say, all the options available, including the creation of digital workflows. In this platform, so that is composed by our logic solver and the engineering tool, there are our engineering tool is the SealWorks that is already having good features, i 4.0 features and plugins, and all of them are enablers for digitalization of functional safety because they allow, for instance, secure data exchange. They allow to expand functionalities. They allow the creation of this digital workflow. And the first that we made is the automatic proof testing that I'm going to explain a bit more into the use case. Okay, so let's enter into this part of the presentation. Automatic proof testing. If you remember this first scheme of the puzzle pieces, what are the puzzle pieces that we are using to deliver this application, this solution? The minimum set that we need is displayed here. So we need from SLM at least operator maintain, then we need our dashboard, we need the human platform, and of course a number of services for finalizing the integration. How does it work, this automated proof testing? In explaining that, I starting with a comparison. This is a typical number of steps that are used to compose a workflow for testing. And now every company may have different approach or steps, but what is important for me is to focus on the red parts. You know, every step, between every step, there might be data manipulation, data transfer, data copy, and all of that are activities that are highly influenced by human mistakes, or human error is influencing a lot there. Then if you look at the central part, which is the execution of the test itself, we need to send a person in the field, we need to connect manually, maybe handheld with the device, we need to do some manual steps, we need to communicate with someone that is in the control room. And you know, communication is one of the biggest topics in human factors. And as a result of this workflow, what's happened here? We have a one-way workflow. So it's not a real, yes, it's a workflow, but with an end. There is no closed loop of data. So whatever we collect during this process is lost because it's then remaining in a PDF or a Word or an Excel or a database. So there is no way to reuse this data. Conversely, when we talk about a digital workflow for automatic proof testing, then we start from data in SLM, in the lifecycle management tool, then we get the notification when the test is due. This is passed into our dashboards, and from the dashboards, the operator can trigger the test. Of course, we need to integrate the solution with the bypass procedures that clients have. And this is possible because usually the bypass of a safety device is managed by the safety PLC. So for us, using HIMA, this is possible. Sorry. Then we can trigger the test, and what's happening here in the central part. First of all, you see the difference in terms of duration. The test will be automatically managed by the logic solver and the engineering tool of HIMA through a HIMA Smart Safety Test. And this lasts minutes. What does it mean? For a complex smart transmitter using hard communication, we can test the device in accordance to the procedures that we read in the safety manual in minutes. While the same procedure may take hours, sending someone, connecting, communication, all of that. The results are then transferred back to the dashboard for visualization. Then the test event is created and logged in SLM, where a second person may validate it before they becomes part of calculation of statistical failure rates, tier 3 metrics, and all of the safety parameters. When this happens, then also the data in the dashboard will refresh, because then we read the updated calculation. This is bringing, in terms of added value, several things. We have reduced human factor in the entire process. We reduce the amount of time for every test. We can optimize the proof test interval because this test can be done also in production. You don't need to wait for shutdown to manage this kind of test. Then you can free up resources and let them focus on improvements and not on routine activities. And the process itself is collecting data and reusing data in an automatic way. How this dashboard now for automatic proof tests look like a bit more in detail. So this is just to give you some highlight what are the main parts. In this upper area, we read information from the test group in SLM. We click on a test group, we have the list of devices here, and then we can target from this push button, the automatic test request. Of course, the device needs to be bypassed if we are in operation. And then the safety PLC triggers a sequence of testing activities based on the safety manual, as I said, and we use hard protocol for managing these activities. Just on the layout of the dashboard itself, you see on the bottom part, every dashboard has a system log, so it's collecting what's happening in this dashboard for every SIF, and there is an internal journal, so every user can add comments or remarks for this specific test group here in the system directory. The sequence of testing that is fully embedded in our HIMA C3 certified logic solver. So this is important because it's, I would say, unique characteristic for this solution. The test is driven and is executed by a certified logic solver, C3 certified logic solver. And this is the steps. These are the steps. We read the hard safety parameter and we save them. Then we unlock the device out of SIF mode. Then we drive the test sequence, we record the test results, and before to lock again the SIF mode, we compare again the hard safety parameters with the one that we read at the beginning, in order to make sure that there is no manipulation of data that maybe by mistake happened or whatever could have been happened. We avoid that by making this check and making sure that nobody touched during this process the safety parameters. Then we lock this back, then we have a complete loop created for this. We delivered already a number of smart safety test application solution, which is, you see, the core tool that is at the center of this workflow for several clients, and the success story I can share because it was publicly published in our internet website. It is about Evonik in Germany, that they used human smart safety test to drive automatic partial stroke of certain safety flaps valves in the propane distillation unit. This allowed Evonik to extend the proof test cycle from 1 year to 3. Because we are so flexible with this kind of automatic proof testing, every proof testing interval was really customized based on an analysis of the breakaway torque to prevent systematic issues creation on the valve itself. And they saved at least 1 day of production loss every year. The test, because we are in Germany, and NAMUR recommendations are really strongly used. We have been able to follow NAMUR recommendations as well in the testing strategy, and we combine partial stroke with the HIMA hard solution so that was the safety logic solver itself to drive the test. And last but not least, there is the embedded automatic generation of test reports, because for authority and for, I would say, internal auditing, this was still required. You can read more about that in the link that we leave you in the HIMA website. And this smart safety test, the smart safety test, has been awarded last year as Best of Industry Award in Europe. So this is something that we are quite proud for our development. Second use case is SIF performance analysis. This is less technology-based, and more, I would say, in integrating different models, different way of using SLM, and integrating SLM with different components of our solution. In this case, we basically used SLM with our expert consultant, so that our expert function safety consultant, based on their know-how and the usage of SLM, have been able to offer receive performance analysis as a service. So this means that we got input information, input data from customer. We made a quality check on them. We imported them in SLM. We have a license that we use for consultancies. Then using operator maintain analytics, we build then a report for the customer, and then we discuss the results and any regular recommendation with them, and we continue consulting them, supporting them, I would say, during the years with this kind of continuous process of services. This is another way of looking at creating tailored solutions through integrations. In this case, this is useful sometimes when customers are not ready for the leap into digitalization, but still they understand how important it is making data analysis, making analysis of performances, and we have seen that this is, I would say, precondition then for letting them having their own license and having their own digitalization journey. So I would say it's a kind of preliminary step before they go into their own digitalization way. We use that quite regularly, this kind of approach of safety as a service for HEMA clients in APAC. I could not list the number of clients because of confidentiality, but I can tell you that this is, I would say, normal practice in APAC for certain customers to have this kind of relationship, and we are able to deliver in this way halves of the LOGA facilitation, PFD calculation, SIM verification, and then, as I said at the beginning, going into the operator maintain, also performance analysis, status of disease, reporting for authority inspection, and evaluation prior use for design improvement. So this is, again, in this case, is using SLM as a tool and leveraging leveraging the capabilities and competencies of experts and consultants. Conclusion. So you can see that HEMA has clear digitalization strategy for functional safety. We develop our concept to integration in order to be able to customize for customer needs specific application and specific solution. SLM creates the foundation element for further digital expansion. And as I said, for instance, it is key the communication aspects, the API communication. This is something really, really great. And the operator maintain the analytics, the different modules that support compliance. This is, of course, creating the baseline. Safety lifecycle digitalization innovation is the new critical front of supporting customer. This is my personal opinion because I saw that in the past. There are a lot of opportunities or possibilities to be more or less compliant during the engineering steps. This is more mature, I would say, in engineering contractors, in final end users. But then when it comes to operation, then we talk about time of 20, 30 years when maintaining compliance with standards is really hard. It's really hard not because of bad will of customers, but because everything is based on data. And we were not in the past 10 years, 15 years ago, maybe up to the level to get this challenge, but now we can. Now we can do this. The integration of digital solution is indeed opening new horizons and opportunity based on consulting expertise. So this is what is allowing us to select what to put together, in which way to drive the development of the dashboards, which kind of processes can be developed to support customers. So know-how on functional safety is key, is center. Then, of course, partnership. We need to have the right partner on our side to offer this kind of integrated solution. And of course, this is something that is in the human DNA technology and for related to safety automation systems. Thank you for your attention. I hope I kept you all awake. I could not see your face, so I will not be offended if you close the eyes during the presentation. I still have 12 minutes based on my clock here, so I will be more than happy to get questions if any.
Any questions?
No. Promoting it? One's got that.
Yeah, I have a curiosity about this operation and analytics. This is kind of a customization that HEMA and Mangan did on the operation maintain module before. So in Motiva, we do kind of a yearly demand event analysis. I wonder, I have curiosity about so what kind of customization you did on the operation maintain module for that analytics. Did that cover demand events analysis, also bypass event analysis?
I was not able to hear 100% the question because it was a bit low volume. What I understand is the question was around which kind of events we are able to log and pass to SLM. Is that the question?
It's about the demand event, the analytics that they have on the operation module.
Yeah, so analytics around the demand events in the operate maintain module.
Yeah, okay. So actually we use the full power of SLM, so we don't have any additional analytic. What we just do is reading variables from live system and packing them, interpreting them into events. And these events are fitting into the events that SLM can receive. So SLM can receive a number of events related to demand events, false trips, detected failures, or stuff like that. Bypassing events, all of them can be read by our system with an additional, I would say, smart approach because we have logics that interpret variables, and we know if a trip was a safe trip or a spurious trip or a trip with failures. And if it is a trip with failures, which is the element that is failing? And then logging also already the device event failure. So this is, I would say, boosting a bit the event, boosting the event creation and the event synchronization in SLM, so that in SLM everything arrives sorted, already pre-filled, and then there are less steps for the validation of the event. And what I experienced in the past is that if an event is created today, maybe it is discussed in 3 months. In 3 months, you need to reopen everything and you need to discuss it because you cannot remember it. So this pre-filling of the events allow us to offer customers together with the analytics of SLM and the managing of operator maintain from SLM a shorter way, a quicker way, where you don't need to readdress the same topics after the event.
Right. It takes the process you're currently running, where you're just getting the generic, trip at a top level and bringing that in as an event record. What they're doing actually is at a much lower level. They're actually determining what some of those causalities are, and then pre-populating all of that data set. That instead of normally you go through the AER workflow, right? You're going to tell the system what was deficient, right, or what was the actual end result. What they're doing is actually calculating that data, bringing it in, and then pre-populating it, sending it directly into SLM through the API, instead of having to necessarily go through that rationalization. And so that's that process that they're undertaking. So it's at a deeper level within the actual controller side on HEMA, and then they're bringing it back in.
Okay.
Yeah.
Yeah. Correct. And the same can be done because the variables we find in our HIMA systems every logic solver is using the same variables more or less, maybe different name. So the same can be then moved into an historian and then bringing them from an historian. So when comes monitoring activities, the same can be done. Doesn't matter the logic solver when instead we need to drive active workflow like the automatic proof testing, then we need to use our human logic solvers. Basically, this is the limitation of, I would say, the differentiation between monitoring activities and active workflow.
Excellent.
All right.
Any others?
Any other questions?
Great.
Excellent.
Well, thank you very much for doing your presentation. We appreciate it.
Thanks for inviting, and I hope to get in touch with you and other colleagues in the audience. And for any other follow-up, as I mentioned, HIMA colleagues are there in presence.
Great.
Thanks a lot.
Wonderful. Thank you, Marco.
Thank you.
All right.
Bye-bye.
All right, guys, we're going to take a bio break, get some coffee, get some water, and then we'll come back. Yeah, what time? 10:50? Yeah, about 10 minutes. That's why I was putting up the screen so it's a bluish white background and see if he gets a better shot. Better, worse? What's the brightness on this thing?
Well, I might.
Hey, it's all right.
We had emergency at work.
Oh no.
So
He doesn't want to move one even closer, or no? No, this is what would control that. I don't know.
Oh, we'll see then.
Here, you might be able to do menu and look at it. Just don't hit input. It's got to be a menu for brightness. Back up one. I give you one white.
Yeah, good old white one.
Yeah, should be good. Oh, sucks for nothing. All right. Testing, testing. With the mic, testing. Is the mic on? I don't hear anything. I mean, it's on, but I don't hear anything right here.
No, it wouldn't be playing through the roof, would it?
Well, sure, but also, so where's the mic for that?
There.
Right. So we're playing for the room, but whatever it picks up for the room, it picks up for that too, right?
Yeah.
So then if it's not picking up anything for the room, then it's not going to pick up anything for that.
Confused me.
Yeah. If the room isn't, if it's not picking up for the room,
Yeah.
if the room can't hear my voice through the mic and the speakers, then how can that?
That will pick up your voice through that.
But do you hear it? Is it directly connected? Like, is it directly plugged into the laptop?
USB,
Or?
yeah. USB connection.
Ah, okay.
Oh, I see what you're saying.
Okay, gotcha.
Yeah, it's USB.
So a connection.
Yeah.
All right.
Oh, you've got there in the end.
Yeah. All right.
You next?
No.
Oh.
All right. Testing. 1, 2. Testing with the mic for the live feed.
They said they were he had some sort of
Here to start getting back to our seats when we start again. All right, everyone's still in the conversation. Let's go ahead and get back to our seats. We'll continue the presentation. Dean, we're live? All right. We are live right now. All right, everyone, welcome back. And for everyone online, welcome back as well. We are going to go through until lunch just some things that we've been working on at MSS. We'll start with some of the roadmap of our features and some of the technology we've been applying and what we're going to be doing over the next couple of years. And then we'll get into our support system and some of our training, the applications around our training that we're going to be doing in Learning Center. So to begin with, just this first view, we're going to look at some items we're going to be working on over the next 2 years into 2024 and into 2025. So this is going to be some of the things that some of our users have been asking for, some of the things that we've been meaning to get to, just over some general types of items right here around data management, operate maintain module, functionalities, some instrumented systems module functionalities, API reporting, which is going to be a big one that Jeremy's going to get into with the technology that we're going into, and then some HAZOP LOPA items. And also what we'll continue to be doing will be some general customer specified modifications and requests. I mean, that's just continuous continuous things that we're working on as those ticket features or ticket requests come in for the features. So one thing we've had an issue with in the past has been inadvertent data loss due to some just accidental deletions or accidental unlinks. We're going to fix that with data archiving. It's going to be something where we're not going to necessarily eliminate data immediately, but when we do when we do get rid of certain data, we're going to send it into an archive status so that we have that ability to bring it back up online if it is basically an undo button. So recyclement, yeah, there we go. What this is also going to allow us to do is to put in, once we get done with, say, instrumentation data and event data that occurs, we can move that into archive status and still have that that data available for calculations from past events. Go ahead.
So for the archive, yeah, like it'll be like kind of like a recycle bin, like you have on Windows. You know, your recycle stays in there. Can you choose to keep things permanently? Can you choose to get rid of things immediately? Like maybe you made it sit and you didn't mean to. You might not want to keep it in your archive. Can you clear it out quickly, and can you choose some things to stay permanently, like a old low bar or something?
Yeah, of course. That'd be part of the whole functionality of it, where if we can, the point of us having that data archive is to send something over there immediately with the option to clear it out after. So if, in case you do find where we have run into this in the past, where you accidentally delete something when you didn't mean to delete it, you meant to unlink it, but then you send it to the data archive and you just restore it back to the way it was, instead of having to rebuild it from scratch. Some other things we'll work on in the general data management and configuration topic here is some customization to the export adapter functionality. One issue that we continue to have from clients is when we export data out into flat files, then there's a lot of manipulation of that data that has to occur in order to pull it back in the right format. So we're gonna plan to put in some configuration, customization functionality around how you want to pull that data out. So basically, kind of like writing a report, or configuring a report, but configuring how you want to pull data out in a specific format, so you can pull data out and pull it in just immediately in that same kind of format that is user modified or user configured. What we're also going to do is expand import functionality to system table and checklist configurations. So right now we've already figured out how to import reference tables. We'll apply that same type of functionality to checklist importing. This is checklist configurations, not the actual checklist data. And then also to drop-downs, unit of measures, anything else that we have in the system module that is the user or system or instance configured items. Around our operate maintain module, what we've already completed was a proof of concept at the end of last year for test procedure generation using our checklist functionality. And some of y'all in this room have seen this functionality already. It's kind of rudimentary right now, but we plan to expand that functionality into actual proof test generation of documentation. So proof test documentation generation. This is still going to be dependent on the instrumentation types of manufacturer or client-specific information that we want to pull data out and be able to print that off as a document so that you can go out, run your test, and pull it back into SLM. What this will get into eventually will be, and Kevin's going to actually talk about this kind of topic, will be around mobile testing of devices. We generate proof test procedures out of SLM based on the instrumentation type, pull that information into a mobile platform to be able to enter that testing data directly in so that there's no paper that you have to actually print out. It just pulls it right in. Further in the operate maintain module, we've been talking about this for a while internally. One continuous issue we tend to see comes to be around the amount of data that is actually pulled in and rendered that slows down the system when it comes to event capturing. And now that we have API and CGI event capturing, the automated event capturing is going to severely increase the amount of data that has to be rendered. So in order to prevent that, we're moving to, or we plan to move to a device event log, I'll call it, where any of that information gets pulled into a single table that's easier to look up, faster to render, and reduces the amount of the memory requirements for the system. Any questions so far?
Let it be like a single entry, like you know how you have 100 device events that are this device, maybe you just have like a single tab there, or will it be like a separate tab on the device itself?
Still gotta figure that out. This is a concept we're gonna be looking for, trying to implement over the next year to 2 years. In the instrumented systems module, we currently have a SIL calculation, which works pretty well. A lot of y'all have been using that. But what we are lacking right now are automated checks against IEC 61511 requirements like minimum hardware fault tolerance, system capability, degraded voting calculation results. We will plan to put more automation into that so that those checks are done immediately instead of having to do those kind of in a manual way to get a result and then check it against those requirements. These the things like the minimum hardware fault tolerance, system capability, those are going to be based on the 61511 tables, so it'll be fully in line with the regulations. The next thing will be the what I'm going to call nested SIL calculations. On occasion, we find that the amount of voting capability that's currently in SLM does not meet the necessity for some of the most complicated SIFs. And this is also how you define your SIFs, so I can put partial blame on some of y'all. But if you do have a very, very complicated SIF that you just can't get around, one thing that we have not addressed so far are those less than 1% SIFs to actually be able to design the architecture in SLM. So what we're going to look at are, like I said, what I'll call nested SIL calculations. We'll see how we can do this in the math, but I don't think it's going to be too much of a problem. We'll get to a point where we can do partial calculations on one, on kind of a partial SIF or a group, and then just relay that group into another SIF at a lower level to get what ends up being multiple layers. Okay. Yeah, kind of two or. It'll feed the other one, yeah. So for instance, if you have a whole group that you want to have a really complicated group, just putting it into another calculation as a final endpoint, the math ends up working out correctly because it just ends up combining together at multiple layers. But this is something I want to get to. I've been wanting to get to for a while to be able to address the more complicated SIFs that, as you see an example right here. And then last thing on this instrument systems module, what we have seen as we've been pulling in PHA data has been times where functions need to either be upgraded to SIFs or downgraded to non-SIF items. What we have to do right now is actually recreate those functions as different ones. So this idea actually came from a couple of y'all in here, would be to transition these function types so that we really just have really kind of one function type that is capable of being identified as a SIF, as a IPF, interlog, BDCS, whatever you want to call them, it doesn't really matter to me. But the functionality of designing them still stays the same. What changes is the requirements and the fields that are available on each of the different types as we just change them over. Changing them over would be a process to approve those changeover types, but again, in concept, it's something that we want to approach. How we're going to do it, still have to kind of work that out and get input from some of y'all as to how really that should work. Yes, Kevin?
So that means that for all the function types, you'll be able to document the actions on all of them, including alarms?
Yes, so if they're all one, as the system sees it, one function, where you just specify what type of function that is, they would share common fields that would just be available based on the type of function that you select. So say all my SRS fields would still exist on all functions, but they would only be visible and used whenever there's a SIF.
So have you corrected so that you can put a final action on an alarm and document that final action?
That'd be part of the transition to do something like this.
Okay, good.
So around reporting, we're increasing our capabilities around our API. And one of the things that we're going to go for in the second half of this year and going into 2025, this will be kind of a longer process to get this done, but we're going to go directly to the manufacturers to get instrumentation of failure rates. This is going to allow us to start building our own failure rate database that doesn't come from SERH or ORITA. This is going to be something that we're going to try to provide to the industry, to all of our clients, as a standard addition or standard thing that comes with the instance stand-ups. So in SLM, if we can identify just the manufacturer failure rate directly from them, we don't have to be using generics. We can specify that something's going to be a certain instrumentation type and have those design basis failure rate calculations done immediately. So if you still want to have your own, that's fine. It's just something additional that we want to provide to all of our clients.
So let me ask a little bit about that, right? So you're getting into the operating modules, and realistically, we all want to improve our safety performance. Our manufacturers rarely know about the actual frequency of issues. I mean, I'll tell you, a level bridle failure that the manufacturer will record is going to be maybe 1/1000th of the actual field experience, because most of the time it's some kind of paraffin asphaltene coat type product getting into the bridle that has to be flushed out, right? And that would be detectable in your operating mode modules. How are you going to distinguish what the manufacturer data versus maybe the more valuable aspect of the lifecycle management, which is pulling in the PI data and conglomerating industry data that way? Have you thought about doing industry data from PI using your operating lifecycle rather than the manufacturing? Because plainly, I wouldn't trust the manufacturing data unless you added a 100x factor for failures.
That's a fair point. The fact is that what comes from the manufacturers and what comes from our actual users and say your instance, if you are calculating a bunch of failure rates that way, they don't coincide, they don't replace each other, they just live in parallel, right? So you could have that manufacturer data, you could have your own data as well that comes either from your company standard or from a site-specific usage results. They don't have to override each other. They can be selected independently.
Yeah, I guess my challenge back as a service provider is, how do we work collaboratively to improve safety? So if there is a smaller company that's starting up and is looking for data, they're not necessarily going to have access of a BASF or a Shell or, an ENI. But if they come to you and all you provide them is the manufacturer data, but you also know from your other modules, there's a discrepancy between them, are you helping improve industry safety, or are you actually exposing the entire industry to more regulation and more cost burden because you're actually not using industry best practices?
So you're actually asking what I'm getting into for the next thing. And Jeremy's going to talk about this more in a second too, but um, we're moving our instances into what we're calling containers. These containers are going to allow us to report data through those containers to a higher level. So say for Shell instance, for instance, all of Shell's SLM instances could then be reported up to a higher level where you could share the failure rate data between all those separated instances. Because right now, an instance is an instance of SLM, and you can't share data between. With containerization of these and API reporting, we can actually pull all that data into a higher, a level outside of those specific instances, and then push things like failure rate data back into it. So you can get that collaborative data between multiple clients and multiple instances for specific clients. Does that help?
So is the hope to get clients to electively share not individual transmitters, but overall lifecycle information so that we can improve failure rates as a collective industry?
Precisely.
But we have talked about it for quite a few years, and the difficulty ends up being that sharing part. It's so big. This is your. That's right.
There are legal implications. It is something we're going to have to work with.
This is the technological answer. We all want to share. It's just whether we're allowed to.
Right. Yeah.
But there are other databases like
Yep.
And we can continue to use ones like those. This is just giving us more of an option to pull that data up through multiple clients, so multiple instances, multiple usages, so that we can get it more to get that failure rate data more to an industry standard that competes with those other databases that are already generated.
Yeah, when you run a SoCalc in SLM, you get a table, multiple results. You can have, manufacturer results, external results, exeter results. I mean, you're not just getting one result, so you will see all these different failure rates as long as you're using it. You can compare it for yourself. I mean, see where you end up.
Yep.
All right, and then since we got into it, as you see here with the containerization, we're going to be using the APIs to pull that data up into reporting capabilities that are going to allow us to show, more combined reports of a particular company. So say if this actually would allow us to, say for any specific client, you could have a separate instance of SLM for every site usage, and then just combine all that data up to a corporate level to be able to show the health of those sites.
I'd be really interested if in a future presentation you could roll up without listing companies what the deviations look like between frequency data, and maybe that could help spur information collaboration if you can remove all references to whose data it is and start comparing. I bet there would be some very interesting statement references that would love to see that data.
Completely agree.
3 months of legal first.
Yeah, exactly.
All right, I think this is the last one. What we'll do, what we'll also plan to do for configuring risk matrices is to put, I see Philip laughing here, is to put some visualization to those risk matrix configurations so that you don't have to go through into the tables to do this. And then additionally, we want to increase the resolution of these risk matrices to the PHA studies so that we can pull in older data and also older PHA data, import that in and have them use the risk matrices that they do. But additionally, if a company's matrix changes, that would not affect previously imported or facilitated PHA studies, has absolute locus. We could just make those changes to the individual studies so that you still have the old risk there in the older studies. Pretty simple one, but something kind of we're seeing more importance to it. Well, that's it for the roadmap. Any questions before Jeremy gets into the technology R&D? Yes, Carolina. That's going to be in the operate maintain module. In the instrument systems. So okay. So the question is, should these test procedure generation be in the instrument systems model because FSA stage 3's required testing procedure to be documented? Okay, that's a fair point. The point of these test procedures was to just generate them based on the instrumentation. Since we are identifying the instrumentation in the SIL calculation architectures, the determination of that instrumentation types for the SRS, we can potentially put them there as well. So that's a fair point. Sure. So in the past, we haven't been using SLM for generating test procedures and making FSA3s dependent on that. If we're going to do that moving forward, then yeah, we could put them there just as this is as a concept to generate test procedures. So the further we get into this, the more we can work with you, with anybody else who has some input, to put everything into the right location so that we make sure that you get everything you do need, since we're putting more automation into the system itself.
Would you need to put the devices and instrument systems there, or would you just generate based on IO?
Probably just based on IO. Because you're just identifying that for the SRS.
So would you also have based on IO and O&M them, or would there be a discrepancy there between how they're?
Well, the point of the capability of having a difference was that if your SRS requires, or if your SIP is designed to assume a specific instrumentation type, and then when you actually implement that function, if the actual device selection was different, you could document that difference, and maybe go back to change your SRS. But we're getting further into something that would be more around the design of it. The concept stays the same. As we get feedback from y'all, we can change how we approach it, and yeah, and put it on a card, and we'll
Habits, sorry.
Yeah, no problem. But I'm gonna move on to let Jeremy talk here. If y'all got any more questions around roadmap features, go ahead, put it on your cards. We'll address some more of them at the end with the user forum at the end of the day.
Or ask Matt. I might just grab the. I want to. You guys hear me? Can you hear me? Can you hear me? Can you hear me? Hello, hello. Maybe not. Hello. Is this thing dead? Hello. I guess we'll use the other one. All right. Can you hear me now? No. Hello, everyone. Yes, I'm here today. Yeah, thank you very much for coming again. Thank you, Matt. That was a great presentation. And as Matt had said, regarding software features, concepts, ideas, when you have an idea, when you have a concept, you can always either email any one of us if you know our emails, or you can directly just send an email to softwaresupport@manganinc.com. you can go on the website, click on support, send us an inquiry, and we'll absolutely take a look at it and work on it, and we'll see how we can make sure that the software works for you. So I'm going to be here just to talk a little bit about technology, our software technology, and where we're headed, and what some of the things we're working on right now, and some of our aspirational concepts that we're working towards. So that's just going to be a kind of a high-level technology discussion. If I talk too fast, which I typically do, just do the pump the brake. You can do that. That usually lets me visually see that I need to slow down. Thank you, Nigel. And you know, we're just going to have a little bit of a conversation around what we're doing and what we're working on. You know, as far as SLM is concerned, a lot of our customers are kind of mixed between on-premise deployments of SLM and our software as a service product. So obviously, a lot of the folks here are either one or both, or some are all of the above. So you know, we've been working a lot around making our software portable in the sense that it can be delivered and deployed on any type of cloud or any type of customer's deployment, or any public cloud, or even hybrid of those two. And that's something that Matt did talk a little bit about, and that's containerization of our software. Part of our ongoing process is to make it as simple as literally someone typing in a single command line and being able to launch SLM as an application in their environment. And so that's one of our big goals that we've been working towards. We've been doing that now for probably the last year and a half in our development environment. We recently transitioned our production cloud environments to containers, and we're still sort of in that next stage process, and moving towards working on that with our customers. So our customers will be able to we're looking at probably starting in Q1 2015 as they deploy on-premise, having the exact same modalities that we have for deploying our software in the cloud. They'll be able to do that on-premise as well. What this does is it allows our customers to very easily update their own software on-premise. It's one of the more difficult and complex things that typically happens on an on-premise environment. You have a lot of people involved, a lot of different departments. One department manages databases. One department manages applications. Another person's in charge of the firewall and security. And you got to get everybody lined up to be able to just update your software. You all know that is a problem. What we're trying to do is make that much simpler, so that, you know, one part of their organization or their MSP that typically handles their IT side can very quickly and easily update their entire software on-premise for their on-premise deployments. And again, that same technology is already following in the cloud now. So some of those customers that are using the cloud environment are going to be able to see those benefits as well. So that's kind of our big first step in terms of our next generation of deployment technology. Moving on from that, Matt did talk about this a little bit. And I know a lot of people, actually I had a couple of folks this morning had said, hey, can we get some better reporting? Is there some better options for being able to create paper? I know we're a digitalization company, but paper still rules in a lot of cases, right? And there's a lot of times when you want a hard copy, a printout, you want to be able to have access to that paper copy. One of the reasons that we're looking at and moving on, building a new reporting infrastructure framework, our reporting management software in the back end, which was the tried and true SQL Server reporting services, is going to be dead as of the end of this year. Microsoft is going to kill it and make everybody use Power BI and pay a lot of money to use Power BI. So we're not going to do that. So we're going to move on, and actually what we've done is again, part of that containerization and being able to deploy our software very rapidly means we've got to have a better way of deploying and building and managing the reports. And so we are now doing that inside the container, and we're now able to actually deliver those reports faster, and just as pixel perfect as you could with SSRS, we're able to now generate those reports and put them within the instance and not have to have some separate application service doing that. So from a technology perspective, it's simpler, it's faster, and we won't have to be paying Microsoft more money, which everybody has paid them plenty, right? Bill Gates is going to be talking tomorrow, in case you guys are interested, down at the conference, S&P Global tomorrow. And so, yeah, obviously, the other side of this, the discussion points here, we're also working on building new reporting endpoints. Now, we have a lot of customers, and some customers that are very interested in saying, you know what, we just want the data to integrate with our own reporting system. We want to take the data and put it in Tableau. We want to take the data and put it into Power BI. We have Power BI, we might as well use our own data. Perfectly fine. And so what we're trying to do is on the API side, and I've now heard every single one of the presentations from the organizations have all talked about how they're leveraging the API, leveraging the data in SLM. This is going to give you access to that data in a way that you can utilize it within your own reporting and information and your own system. So what we're working towards is every single report that you see in SLM, there's over 127 of those reports. All of that data will be callable and accessible via API. So you can pull that data, and you already can have that generic report and then start making it the way you want to make it, right? And then all the other fields and all the other field data that you would normally have that could come along with that report, you can choose how that works and deploy it and put it into Power BI for yourself. So that's the big piece there. Obviously, we talked about the new report rendering framework. The other stuff of this is where are we going with this? Well, right now we're in process to convert all of those current SLM core reports. We're finishing those. We're looking at the end of Q2 this year, so sometime June, July, we should have all of the core reports in this new framework, and they'll just work. They're just the standard SLM core reports. Those will all be within the framework. And then we're going to start working on the SLM customer reports, right? So almost every single one of our customers have some variations or very special configured reports maybe for their own instance. So those reports, those will actually be converted, and we'll start going down that process throughout the rest of the year. And then we'll have a complete containerized report and reporting system that we can then deliver to our customers as part of that on-premise deployment if they want to choose that, or in general, they'll just have access to that new reporting framework. So that's our aspirational side of that. But you know, I mean, one of the nice things is, you know, the technology we're using is very simple. We all know what HTML looks like these days, but we're able to use, you know, very high-end graphical style sheets that we can now apply to it, and it allows us to basically use generic technology such as, you know, Chrome, which is a browser, right? We use a Chrome technology in the back end that creates a PDF. And we're able to now paginate, make pixel-perfect reports, and not have to have third-party systems underlying that. So that's our big step forward with reporting, as well as, again, it's more reporting and data access, more API access, more access to information coming out of SLM.
So
Go ahead.
You're saying that you can use the API to get the full report in one call?
Yes.
Awesome.
Yes. Here we go. API. Thank you, Kevin. Kevin is a user of the API. I didn't say that out loud. He's got a presentation on that in just a few minutes. So yes, again, the API, I think Amin touched on this, and every single one of the presentations we've had so far is talking about, great, we have the data in SLM, how do we use it? How can we make it actionable? How can we use it within our own processes? And what we're working to do is take our current API, advance the API, and then add the features that our customers are asking for. So there's a number of features that our customers are asking for. Much more detailed endpoints for integration, where you can actually directly just send in a bypass, not necessarily a generic, which we currently do today. You can send in all of the parameters for a bypass. One of the organizations which we heard from today that was talking about that was HEMA. So you're wondering, how does HEMA send all of that data in? These are those kinds of endpoints that we're working on with our customers, and we'll be publishing these as they become available to our customers within the application, within the API, and we'll start going through that. We have new documentation, a new documentation system that comes with our API that we're releasing. If you have the latest version of SLM, you'll have this latest version of this API documentation functionality. You can actually call the API and play with the API from within the actual web interface. You can ask it questions and get the data out from just within the web interface. So that's another, you know, obviously new feature with that. As we said, reporting endpoints. Obviously, we want to be able to have access. We want our customers to be able to say, yeah, I like this report. How do I get access to this data? The actual user interface, the SLM user interface, we're going to be creating there's going to be a small little icon within the user interface on every single view and page. You'll be able to click on that user interface and see what the API call is to get the data that you actually are seeing on the screen. So you say, I want this data, you click on it, it's going to pull up and give you that access to that data. So you can call it in the API, make your report that you need. You'll know what, as you know, not easy to find these hash tags, right? And you're getting all the hash codes for these giant objects. You have no idea what it is. I don't know what a hash is. It sounds like something that, you know, I have with breakfast. So yeah, no, this is, you know, so we actually are trying to focus on making sure that the data is accessible and you know how to get to it. So we'll be talking on those things and presenting some of that as we go forward. The reason why we're going through a lot of this as well is because we are working on a new user interface. I'm not showing you pictures today. We are working on a new user interface, but we obviously understand that we can't change a complete user interface for an enterprise application, but the underlying technology is what we're trying to improve. So we're trying to make it faster, we're trying to make it more streamlined, more designed specifically for today's internet. You know, the original user interface is probably 6 years old, and so there's some better technologies that we can use. Visually and how things function and work, we shouldn't be changing a lot of that. And the reason is, of course, we have people that are trained on how to use and click certain buttons, and I completely understand that. Don't panic, not going to do that. So just understand. But again, we're working on that. Again, as you all know, if you don't update your iPhone like within like 6 months of a new release of a version of the operating system, your phone just starts yelling at you. Well, it gets that same way when you don't upgrade your technology, your underlying technology. So we want to make sure we stay current and keep our technology fresh so that we can deliver the best advancements for our customers. So that's why we're making these UI endpoints. And again, that same sort of scenario where, you know, if you've got a user interface screen that you're looking at and you want to be able to get the data on that screen, well, when we have these UI endpoints, you're going to be able to click and get that data, right? So we need to be able to have access to just getting the raw data, not necessarily the rendered data. So that's one of those pieces. Obviously, we talked a little bit about those integration endpoints. HEMA obviously had a nice discussion on that and how they're using advanced endpoints to actually provide real context data of what's happening at a lower level from a, you know, whenever there's an event that may happen. So that kind of stuff to be able to bring integration, bring data in from the field into SLM. And then the last one is one of the ones that I've been working on with some of our team members is the data and the data model that we have in SLM is very complex. And it's deep and it's complex, and we have instrumentation data, we have these objects that are functions that just about every other system can't really model in a lot of ways. Your ERP doesn't understand them, they just understand instruments and they think you're just trying to replace something in the field. So what we're doing is we are actually building within the actual API a way for computers to understand the model, the actual data model that exists, that is the SLM data itself. And by taking this and making it accessible to computer systems, we're able to actually tell some of the new great advances that we've seen in artificial intelligence. We're able to say, hey, look at this data model. Here's how we explain our data and the data in our application. Now you can ask natural language questions to the data model and start getting responses. So that's where we're headed and working towards. And I'll talk a little bit more about that on these other slides. So where we're headed and what we're trying to be working on in some of our research and some of our technology side is looking at the existing data model that we have within SLM and then making that data model, as we said, accessible to existing artificial intelligence technology, ChatGPT, Llama, and being able to expose our data model so that you can start asking interesting questions. Being able to ask SLM, you know, what are the, you know, safety hazards that I have right now, or find some correlations between plant A and plant B and plant C. You can ask it, and you'll be able to ask it in a natural language. That's the goal of where we're headed. One of the things I think I heard it from Ramon. One of the things I heard, and typically we've been saying this, right, for 15, 20 years. I mean, really, maybe more than that. We've been talking about and searching for the single source of truth. And I think what we've seen a lot of is, you know, we have all of these other systems that are coming in. We, for the longest time, just thought all we needed was a historian. For sure. A historian is going to be the single source of truth. And then all of a sudden, SAP showed up. And they said, well, we're going to be the single source of truth. And then, you know, we had, you know, our maintenance management system said, no, we're going to be the single source of truth. Everybody wanted to be the single source of truth. And what we're finding now and what we're seeing on the industry side is every single one of these software providers is going to be providing an API, or they already have, or they will be, and they do. provide an API. And the reason being is because that data that's in their system is just a piece of that single source of truth. Making correlations between the historian and the ERP and the maintenance management system, as well as the safety management system, is going to be complicated. Having you, me, or any of the really brilliant people in this room write a SQL query, right, to come up with figuring out how to merge all of that data together is probably not going to happen. But that's something that AI excels at. And it excels at it in a way that we honestly, in some cases, don't necessarily fully understand, but we're working on that. But we can ask a natural question in a natural language, and it can pull all of those sources because those data models will get exposed. And those data models are exposed to an AI LLM or a specifically trained transformer model. They're able to actually now understand the details, and again, they understand the data and the data model and how to access and ask that data for information. And then it stores that, right? It says, okay, I now know everything about plant A, and I know everything about the financials of plant A. I know everything about all of the time series data in plant A. I also may have access to a data lake with all sorts of logs of data, and it's pouring through that data, and it now knows when you ask it a question, it can correlate all of those pieces together and give you an answer that has real context. So that's where we see the single source of truth going. So as you progress down the road, it's probably not just sitting in your PI system. It's probably sitting in all sorts of different systems, and the goal is to be able to expose those data models to AI and to machine learning so that it can actually provide you real context. So that's what we're working on, and that's some of the areas that we're trying to investigate. We were talking about some of the ideas and some concepts, change impact analysis, being able to say, ask just a natural question. If I modify, this SIF or this specific instrument is going to, was having an issue, what is going to be the effect of my plant in the next 24 hours? What's the situation? And asking natural questions that you would normally want to be able to ask instead of digging through piles of data, writing SQL queries, writing scripts, generating reports. Why would you need to do that when you're just looking for an answer that has real data and real context? So that's the idea. We talked about some ideas around maybe doing a self-assessment score, some way that we're actually taking a look at all of the data that's within the system, coming up with some sort of a scoring based on how your actual data use and the information that you're putting into the system and how your actual plant is operating based on standards, based on 61511, 61508, looking at how all of that works. And again, these you can give AI the entire standard to tell it what that model looks like, attach that to SLM's current data model and explain where the two correlate and be able to get real answers out of these two. So this is why we're really trying to look at how do we get these advances. And honestly, the best part is we know that there's going to be questions we don't have the answer to yet, and questions that we will want to ask, and we'll be able to ask them, and we'll be able to start getting more insights within our data. Lifecycle cost reduction, everybody talks about cost reduction. Leveraging these technologies and these tools to reduce the overall cost and actually prove that we're seeing, hey, look, I've got the ERP in this system now. I can actually look at what my lifecycle cost is over all of these specific instruments or this one specific SIT. How much did this part of my plant cost me in safety lifecycle cost? From, okay, well, we used SLM or we didn't use SLM. Or we were using this specific transmitter, or we didn't use this specific transmitter. Being able to ask it a natural question, then get that answer back. That's the goal. And I think we're just on the edge of being able to do this. We're already starting to try and interconnect our existing software and our existing technology by expanding, as we had said, those APIs, making it exposed, making it learnable, and being able to have access to that technology and providing it to our customers. So we're working on that as well. If you or your organization has ideas, has initiatives that they want to bring this data in or want to start integrating this type of data, I'm sure you already have initiatives. You probably have entire teams that are focused on just how do we use AI in our technology. Talk to us. We'd love to hear from what you guys are working on. We can show you what we're working on, and I hope you have a chance to. They're telling me to wrap it up. I hope we have a chance to talk and discuss. And I'd be really interested to hear what you guys have to think about it. So that was my topic there. Last but not least, I will I will take questions if you guys have any. The last piece was we have this user group card, these forum question raffle cards. If you want to fill one of those out, we have a couple of really cool gifts that we're going to hand out. Like the first 3 cards, we'll pull them out of the hat. We'll hand out some neat gifts. It'll be done during the user forum. So if you have questions, fill it out and give it a try. And make sure you give the card over to Regine. She's the one that handed you your bag this morning. Yeah, please. And if you have anything on this topic, I guess we're going to do a lunch. If you have any ideas or concepts on my topics or Matt's topics, you can reach out to us or just come and grab us. All right. All right. Thank you. Yeah. Turn it on.
All right, we're going to call an audible here and pause on this. We're going to move the rest of the things that MSS is presented to the end. So we'll just break right now for lunch, and then we'll stop that a little bit early. We're going to try to get back on track at 12:30 to start with Kevin's presentation. All right, so food is in the other room. Dean, if you could come and pause the live stream, and we'll be back at 12:30.
Thank you, man.
Oh.
Start to count down. I don't know what happened to the other lavalier. This was working and now it's not, huh?
You ready?
Oh, I was gonna see if I could get this lavalier to work again for you. I don't know why it wasn't. It is. Want to use lavalier or handheld? You can drop the mic on that one. It's up to you. We can. I mean, you can hand this out to flip it, switch it on, and hand it to somebody if they need it.
Okay.
Let me get you presentation start up. All right.
Can you hear me?
I don't know. Sound check. Go ahead.
Can you hear me?
Yeah.
Okay.
Yeah, I think we're okay.
Do you have a clicker or just?
Yeah, just arrow.
Arrow?
I don't have a clicker. Yeah. Go grab it, please.
Okay. Okay, if everyone can get seated, we're gonna get started. Okay, I'll introduce myself. My name is Kevin Klein. I'm not the actor. I work for Chevron, and I've been at Chevron for almost 13 years now. Before that, I was with Celanese for 5 years as their instrumentation center of excellence lead. And before that was with Monsanto and Solutia for 18 years in various roles there. And Chevron has been using SLM for 6 years, 7 years.
7.
So we've been using SLM. We've got it installed in multiple sites throughout our company. We've been using it to be able to document our functions, but we also are using it to collect data. And so we needed to have a way that we could integrate between different systems to be able to get that data recorded. So we'll do an overview of the application. A lot of the integration was based on APIs. And so originally when the product came out, it didn't have very much on APIs. And through discussions and that, we were able to get access to those. We'll talk about the data structure of what we're moving back and forth. I'll show some of the API calls and how those calls work and what kind of data you get back. And then we'll talk about the benefits. Okay, so when we look at what we have, we've got Mangan SLM. We have our CMMS, which we have just about every CMMS you could ever imagine at Chevron. And the data that goes into the CMMS is minimized because you can only put one failure mode per work order, generally. So that doesn't necessarily represent what the full task that you're doing with an inspection. So we started looking at how we could do mobility and how we could use a tablet to be able to do all the tasks, document the results of each task. We also looked at each task and we said, okay, for each task, what would the failure mode be associated with this task? So it helped the operator or the mechanics when they do the work and they have a failure that they only have a couple of selections to choose what failure mode. So that helps us better understand what happened in the field, and it helps them to be able to get the documentation into that CMMS so that you can analyze what's going on with that data. So we started developing a mobile inspection system. It originally was being developed for fixed equipment so that they could track the wall thickness and how the wall thickness changed over time and be able to pull up the past data in that system, be able to compare it to what they're measuring now, see that progress. And so it had a lot of capabilities in it, so we started looking at doing the same thing with instrumentation to be able to set that up and be able to do the testing all electronically with a tablet so that they could record the results. The challenge with it, one, is in order to do those tests, we have to have certain instrument data in order to know what we're checking the calibration to, what the set points are that you're testing to, and various information on the equipment. And we realized that that data didn't necessarily reside in the CMMS. We had spent a lot of time setting up Mangan, and so we realized that in Mangan we had that data there that would give us the instrument data that we could use then for the testing. So rather than having to manually move the data, we want to automatically have a call from the mobile inspection tool to Mangan to pull the instrument data down so that we would be able to do that inspection. So like everyone, you've got that technician walking out there with a bag full of tools. They've got a bunch of paperwork that they've got to take out there, and they've got to fill in all that data. And, you know, if you look at my handwriting, it's not really good. And a lot of technician handwriting, when they're writing quickly, you can't interpret whether it's an 8, a 6, a 5. What is that thing that they wrote down? And so we had a lot of problems with that. Trying to digitize, you know, they take that report, they run it through a scanner, and now you've got it scanned and you've attached it to the CMMS. But if you want to go see what the results were, you still have to go pull it up manually. There's no way to do anything with it.
Sound familiar.
So doing performance validation, very manual. You need to pull up all those records. You know, I spent hours myself years back with going and pulling up multiple years of records in file cabinets before we digitized everything and tried to see what the performance was. So the other thing is that the quality of the data coming in was not real good either. So one, we weren't getting failure modes in those paper records, so you didn't know how that failure mode occurred or what that failure mode was. The reason that's important, especially with the safety systems, is I could have an application where I have an instrument that is a high trip. I could also have on that same instrument a low trip. But when I look at my failure modes, not all of those failure modes are appropriate for each of those applications. So you need that failure mode in order to help you segregate and look at, for that high trip, here's what my failure rate is. For the low trip, this is what it would be. If I'm doing certain selections, it can help you. You also have no effect type failures. One of the failure modes is SER, which is a minor in service, which isn't really a failure altogether. It's something indicating that you might have something coming. You may have a nameplate that is worn, okay, but that's not affecting the function. You don't want to include those in your failure analysis because those aren't really causing any dangerous failures, okay? So we wanted to improve the quality and also improve the readability of it. So that's why we did the mobility. So we developed a digital solution. Originally, it was 2 parts. We had the database that we could develop the steps. And also with that, when they're doing it in the field, they can take pictures of the equipment. So if someone stepped on a impulse line and bent the impulse line, you could take a picture of it and attach it to that inspection. So it allowed us to do that. Everything was handwritten. Everything now is typed, so you can interpret pretty well what they're saying. We also integrated in there so that when they do identify a failure, we would minimize how many failure modes would be available so they could do a drop down and pick that. In the software, it will pull the data from CMMS on when the work order, the PM, is due. And so in the mobile system, it takes that work order data it merges it with the instrument data and the template, and those all get merged to make an inspection that is specific to that piece of equipment and that plant, that we can then go out and do that inspection. But we needed to have that instrument data, and that's where we look to integrate with SLM to be able to get that data. We also want to be able to upload the data out of that system back into Mangan so that we would have record of the maintenance event. So we looked at how we could do those.
What
Questions? Yeah.
So I think this is great, and it's a really good way to capture information, but I'm thinking about the bad actors, right? So, you know, there are certain places where we have more asphaltenes building up in level bridles, and if they go from 2-week frequency of flushing the bridle to 1 week down to, say, every other day, you know, they're not necessarily, they're doing a function testing for a purpose because they're getting deviation alarms, so it's starting to fail, and they're resetting it. But do you get them to log every time they are function testing or flushing bridles so that you know that's becoming an unreliable device? Or how do you match the bad actors and the frequency that they're doing it versus operations going, man, this is just too much extra work? Because if you're talking about something that's only being tested, you know, every 90 days to a year, start getting into the bad actors that they're going to go work on every couple days. Can you get them to actually use this tool for that, you know, every 2 days logging a new entry? Or
We're focusing on using the CMMS data for doing that tracking. Okay. Once we identify a failure, the technicians are creating a corrective work order. And in that corrective work order, it would have the information as far as the failure mode and what they're working on specific to that piece of equipment. So then you could analyze those records. We haven't looked at that part of it.
yeah, I wasn't talking about like something that needs a CM, but it's just, you know, your fluid has a lot of asphaltene, so you can't do anything. It will plug every, you know, 14 days if they don't go flush it. And if the fluid, if the composition changes a little bit, or you get a different crude stock and it switches from 14 to 7, operations knows, but do we get that information to feed back into our reliability information that they're now having to switch the testing interval to 7 days instead of 14 because the crude changed?
If it's a PM that they're doing and they're following a checklist to go do that check, then yes, it would be recorded.
Okay.
And they would, to change that interval, they would have to go into the CMMS and change that interval. And so the mobile system relies on the CMMS to tell it when it needs to be done. Okay. So it would get those records and we would be able to see if there were multiple failures from the results.
Yeah, I was just curious because a lot of our stuff, when it gets to a certain point, it's like operator rounds or not actual in a recorded system, or it's just call outs where the control room calls the deck operator. And after a while, you pick up that the deck operators are always, the field operator's always tied up, right? But it takes us a little while to figure out where they're always spending their time.
Yeah, I mean, that's always a challenge. So the main thing was downloading data, how to get at that data, how to be able to pull the data, and then how to put the data back in so that we had a record of those events. First issue that we ran into was, you know, normally you set up a test event and that's how you record the what you did. But we couldn't upload data to a test event. So we used the maintenance event to do that upload, because with the test event, it has to be related to a test group, and there was no easy way to make that connection. So we just did it as a maintenance event in there. Also, to get around the issue with the number of failure modes that you could record, rather than do one entry for the whole PM, we would do a separate entry for each task. So that way you could see how each of those tasks worked, whether they passed or failed, and then you could see the results of those. So like on a valve, it would record the valve opening and the valve closing time and leakage rate, so that way you would have a record of those numbers that you could then trend. The other thing was, we had only one failure mode, like I was saying, for an event. So we decided to do multiple events to record the full information. So, okay, we're going to use Mangan as a system of record for the instrument data. So a lot of our plants had put that data in there, so it served as one place that had the data. A lot of the plants were built using SPI, but as far as people keeping those up to date, it's not very good, right? And some sites, they kept that data as spreadsheets, which didn't necessarily help either. So by having Mangan SLM and putting all that data in there now, so this originally, when we started down this path, we were taking the data, exporting it out of Mangan, massaging the data into one spreadsheet to then load that data into the mobile inspection system. So it was very manual. We had, you had to do several downloads out of Mangan in order to get all the data together. And so that was a lot of work that we needed to do, and we wanted to look at how we could minimize that and make that a lot easier. And then also the write back, we developed a report out of the mobile inspection so that it would give us in the format of a smart input for Mangan. And we would have all the data there, and then we would do 2 imports with it because you had to create the device event and the maintenance event. So those were 2 imports. So you had to import that file twice. And if you're doing this on a regular basis, on a daily basis, that would be a lot of time to be able to do that. So I'm going to talk mainly about the data extraction that we did. The first thing we needed to do was get the data for the device and get that information. Then we needed to find the parent of that device. So as you know, with Mangan, there's several different layers of parents. So we needed to get the right parent to get some of the information. The set points are under one of the parents. So the input parent would have, under it, it would have set point. So you need to call the parent and get the set point from that parent. Yes. And then also from the parent, there was some data on the instrument that was there. Some was at the device level, so we had to have a way to pull that, all that data together for the inspection. Also, in order to put the data back, we needed to know more than just the child, the device, but we needed to know the function type and the function name. So through those calls, we would have to gather all that data together to put into the mobile inspection so it had all the information to then be able to write back to the system.
What about you have multiple functions associated to the same device?
If you have multiple functions, you only need one function in order to write the record to the device. Okay. So we just picked one of the functions and used that. Here's where that hash comes from.
Yeah.
Yes.
Putting safe and non-safe devices, or this specifically just was safe?
This was primarily for SIF, IPLs, alarms. So we need to get the hash. In college days, that meant something different.
Right.
So here's our instrument tag. And so we did this call to pull that instrument tag. And from that instrument tag, this is an abbreviated list, but we got a bunch of data on that transmitter. We got the accuracy of it. We got the calibrated range, what type of device, if there were any nodes. It was a level differential pressure with 2 seals, manufacturer Yokogawa, and it gave us the hash of the generic model. And then here's the generic model number and the description of that device. So now that I've got the hash, now I can use that hash to then get the parents of it. So it'll get you all the parents of that, all the way up the structure. I'm only showing 2 of the parents that were in that list, but you can get all of those parents. From those parent calls, you get the hash for the parent, you get the name of it, what type of ID it is. So the top one is an input, and then here is a SIF. So this is the name of the SIF that we were dealing with in that test. So now I've got those 2 information and the hash that goes with it. And you can do all this with the little test system. It's pretty cool. So now that I've got that hash, now I'm going to look for the calibrated range. Okay. And so here I'm making a call on the input object. And here I'm getting the information on that. Here's my engineering units, high, low, unit of measure, that I can then use for the calibration information in that equipment for the mobility. Getting the set points. So then here I'm calling for the children of the input, which the set points are children of that input. And from there, we were able to get the set point. Here's a low set point at 100 inches of water. We have one here at 150 inches of water. And so now we've got the data on the various trip points. Remember, when your technician is going out and doing that inspection, he doesn't necessarily care, or she doesn't care what that device is connected to. They want to make sure that that device is working. And so we pull all of the trip points when we pull for that, so that we know all of the things we're looking for. So this was how the steps to go through. Our programmers put this all together in a program. I've got the 6, 7, 8 pages that they use to combine all this stuff. And so that allowed us to be able to pull that data, put it into the mobile inspection. So when we get the work order from the CMMS, we would grab the tag, and then we would use that tag to then do the API calls to get all the data that we needed.
Just a question on the programming that you're using. So the object IDs are something you're specifying, right? So do you automatically query all the object IDs underneath that level transmitter when in your application? So if they go and do an operational change and add a high to that one that only had a high, high, low, low, and low, would your mobile app pick up that there's now a high value in addition to the high, high, or do you have to reload and reprogram that there was a change in the SLM database?
So every time that we get a work order for the instrument, we would do an API call to Mangan to pull the current data.
But you pull all the object IDs
Mm-hmm.
all the object
Yeah.
IDs. Okay.
We go through the same process and pull all that information to make sure nothing has changed. Okay.
Get a fresh copy of set points.
Well, I wasn't thinking just set points, but you know, in this case, you have high, high, low, low, low. If somebody added a high, does it actually recognize that there is a new object ID in the call?
Yes. So, that's for downloading that data. The upload, we're still working with Mangan on simplifying it. Right now, you can do it with several API calls, which is a little more difficult, but they are working on a way to do it with a single call to do that maintenance event. Okay. So with the use of this, it's reducing the amount of labor and the time that the supervisors are going to have to take to be able to upload the data into Mangan or download the data from Mangan. It gives us a better way to analyze the data from that, and then it helps us with a one source of the instrument data. So now all those spreadsheets and that everyone's using now, you can, set it up in there and be able to pull all the data directly. Currently, we don't have exposed the span information on our devices, but we're looking to get that exposed as well. So that way, you can have your span information documented and then your engineering unit. So if you're doing a level gauge or a level transmitter, you're going to have your calibration, which is the span of the transmitter, and then you're going to have your 0 to 100% for your engineering units. Questions?
So, can you talk a little bit more how this interfaces with SAP? And like we have quality control questions in SAP about passing, failing, etc. Are all your questions now to verify things are working now being tracked in the SLM software, or do you still track, quality control questions in your SAP maintenance system? To auto trigger corrective maintenance. How does like your maintenance system like an SAP compare to what you're putting in this, and where are the overlaps versus where have you segmented one task versus the other?
So in SAP, you only have one set of data for the PM, and it's based on your equipment that you have identified for that PM. So there's no way to document all the steps. If you have multiple failures, there's no way to put in the multiple failure modes. So that's why, we're using the Mangan to be able to put each of the maintenance tasks in there. That way we can record the failure mode and the pass fail for each of them and have a record of that.
But every time you have a failed method that can't be immediately corrected, you still keep that in the SAP system?
Yeah, anytime you have a failure that requires a correction, we're having them fill out a corrective work order to the specific piece of equipment that failed. Okay. And so we have a separate system that we're developing for analyzing the SAP data to pull all those records and analyze, see what the failure rate is, and see what the limitations on that data are. Other questions? Okay.
Thank you.
Well, thank you.
You good on this one here, or are you good? I'm gonna leave this one up. All right. All right. right, this next presenter needs no real introduction. Obviously, I think we all know him. It's Ronak Patel.
Thank you, Jeremy. All right, so good afternoon. It's my pleasure to be here with you today at the 2024 Safety Lifecycle Management User Conference. I would like to start off by thanking Motiva for graciously hosting this year's event, and also welcome and recognize the distinguished members of the Nigerian Upstream Petroleum Regulatory Commission, as well as the Nigerian Midstream Downstream Petroleum Regulatory Authority, for making the time to travel all the way from Nigeria to attend and participate in this meaningful event. It's also great to see so many users here today that continue to champion process and functional safety management, relentlessly investing, as we've seen, multi-year implementations and discontinued strategies, and pushing the envelope when it comes to providing greater risk transparency and ensuring operational integrity across the industry. In addition, I'd like to appreciate the management of Mangan Software Solutions for organizing a valuable forum that enables clients and partners to collaborate, exchange ideas, and share best practices. Today, my focus will be on discussing the importance of regulatory standards and the pivotal role digital platforms play, such as SLM, in establishing benchmarks for regulatory safety and compliance. So I'd like to start out by examining a few past incidents. I think we're all very familiar with some of these incidents, but it's always great to kind of take stock, reflect kind of to what brought us here, that have directly shaped the development of safety regulations and standards that guide our current operations. So the first and foremost is the Deepwater Horizon spill of 2010. This environmental disaster serves as a stark reminder of the consequences of cutting corners on safety. The blowout and fire on the Deepwater Horizon rig resulted in the loss of 11 lives, the release of millions of barrels of oil into the Gulf of Mexico, and immense environmental damage. Investigations revealed a culture of disregarded safety protocols in favor of faster production, highlighting the need for stricter regulations and enforcement. Next is the Texas City refinery explosion of 2005. This incident, where a series of explosions ripped through a BP refinery, tragically took the lives of 15 workers and injured hundreds more. The Chemical Safety and Hazards Investigation Board found that failures in process safety management, including inadequate training, maintenance, and bypassing of safety systems, were a contributing factor. These disasters led to increased focus on process safety standards and a renowned commitment for worker safety within the industry. We also have Piper Alpha platform of 1988. This North Sea platform fire stands as one of the worst accidents of oil and gas history. A series of equipment failures and flawed safety procedures resulted in an inferno that claimed the lives of 167 workers. The Piper Alpha disaster prompted significant changes in safety regulations in the North Sea and oil and gas industry, one of which was the establishment of the Health Safety Executive in the UK. We also have the Bhopal tragedy of 1984. It is considered to be the world's worst industrial disaster. The Bhopal gas leak released gas from a Union Carbide pesticides facility in India. Estimates suggest thousands died within days, and tens of thousands more have suffered long-term health consequences. The accident exposed critical failures in safety protocol, maintenance, and emergency protocols. It also raised serious questions about the accountability of multinational corporations operating in developing countries. The Bhopal disaster led to increased scrutiny of safety standards in the chemical industry and highlighted the importance of community awareness and emergency preparation and planning. These are just a few examples, but they all underscore the critical role of safety standards in preventing tragedies, across the industry. By enforcing regulations and maintaining robust safety management systems, organizations can protect their employees, the environment, and ultimately the bottom line. So moving on forward to functional safety, right? So functional safety ensures that safety systems at the base level reliably perform the intended functions to prevent or mitigate accidents in hazardous industries like oil and gas. Failures in safety critical systems can lead to catastrophic events, endangering human lives, damaging the environment, and causing financial reputation losses. Various regulatory bodies worldwide establish standards and regulations to govern safety in the oil and gas sector. Understanding and complying with these regulations are essential for ensuring safe operations and minimizing risk. Regulatory bodies like NUPRC and NMDPRA in Nigeria, OSHA in the US, Bureau of Safety Environmental Enforcement for the Gulf of Mexico, the Health Safety Executive in the UK, the Petroleum Safety Authority in Norway, the National Offshore Petroleum Safety Environmental Management Authority in Australia, as well as the Ministry of Manpower in Singapore, are just to name a few that all play a critical role in setting guidelines and regulations to ensure safety requirements are met. Compliance with these regulations is essential for maintaining standards in the oil and gas industry. So when it comes to understanding functional safety, it refers to the ability of safety-related systems to correctly prevent or mitigate hazardous events. It encompasses the design, implementation, and operation of safety systems to achieve the desired level of risk reduction. Key concepts include risk assessments and management. Risk assessments involve identifying hazards, analyzing their potential consequences, and determining suitable risk control measures. Risk management includes risk reduction through safety instrumented systems and other safety measures. Edition 2 of IEC 61511 places a significant emphasis on functional safety management system. This edition recognizes that many incidents occur due to systematic failures, which encompass failures in specification, standard operating procedures, design, and other aspects of the safety lifecycle. Now, to mitigate these risks, Edition 2 underscores the necessity for rigorous assessment and management of functional safety throughout the lifecycle. This includes comprehensive functional safety assessments, verification activities, as well as regular audits. A key element of IEC 61511 Edition 2 is that conducting functional safety assessments to verify compliance with safety requirements and standards. These assessments play a crucial role in evaluating the effectiveness of safety measures within a system or process. By systematically examining safety functions and their performance, organizations can identify potential hazards, assess risks, and ensure the safety integrity levels are met. Now, functional safety assessments provide valuable insights that enable organizations to enable the reliability, integrity, and safety of their systems, ultimately reducing the likelihood of accidents and incidents. FSAs are mandatory per Edition 2 of the international standard and require one senior, competent, independent person that is not involved in the project design team for stages 1 through 3, or not involved in the operations and maintenance for stages 4 and 5 of the FSA. And also, there's a big difference between functional safety assessments and audits. So functional safety assessment is a detailed review of all the aspects of a specific stage of the safety lifecycle. The timing of separate FSA stages is aligned with different project milestones is based on where work would be performed most cost effectively, as opposed to a single FSA performed at the end of the project. On the other hand, functional safety audit reviews information, documents, reports to determine whether to find evidence that the functional safety management system is in place and followed accurately. Now, kind of tying this all together to process safety lifecycle management, right? We hear a lot about functional safety, but process safety lifecycle, process safety is where it all starts, is that process safety management involves managing risks throughout the lifecycle of a process, from design and construction all the way to operations and decommissioning. It encompasses process safety engineering management systems, operation procedures to prevent and mitigate process-related risks. Now, regulatory frameworks often require organizations to implement comprehensive process safety management systems to ensure compliance. Process safety lifecycle management provides a structured approach to meeting regulatory obligations and achieving operational excellence. Process safety lifecycle management and functional safety standards share common principles. So all their different phrases and terms, they're very much aligned, such as risk assessment, hazard analysis, and performance monitoring. They call common elements of both. Now, integration of process safety and functional safety enhances the overall safety performance and fosters a holistic approach to risk management. So when it comes to international standards, an overview of major regulatory standards includes the IEC, which is an International Electrotechnical Commission standard, such as 61508 and 61511, which is the functional safety for the process sector. These two are widely recognized. We also have the American Petroleum Institute for API RP14C, which provides guidelines for specific to oil and gas industry. And we also have the Occupational and Self-Health Administration regulations in the United States that also influence safety standards. Some of the safety legislations include the European Offshore Safety Directive, commonly known as the OSD. This is a piece of legislation enacted by the European Union aimed at enhancing safety for offshore oil and gas operations within the EU member states. The main objective include performing comprehensive risk assessments, emergency response, implementation of safety and environmental management systems, they call them SEMS, the independent verification of safety and environmental performance to ensure compliance to these regulatory requirements, as well as cooperative information sharing requirements amongst the operators operating under their jurisdiction. Another example is that we have the Singapore safety case regime, which is employed primarily in the context of major hazard installations. They call them MHIs. Now, the safety case being an approach to assessing and managing major hazards associated with industrial activities, it requires operators of MHIs to demonstrate that they have identified potential major hazards, assess the risks associated with them, and implemented adequate measures to control these risks on a periodic basis. The safety case regime in Singapore emphasizes the importance of proactive management and continuous improvement. Which now brings us to the case of periodic versus continuous safety. So while we have done well to get to where we are, we face new challenges in the road ahead. These safety legislations require yet another set of static documentation to be maintained, managed, and submitted periodically. Regulatory revalidations occur periodically, once every 3 to 5 years, where facilities with major hazards increasingly operate 24 hours a day, 7 days a week, 365 days a year to keep up with global demand of energy, especially chemicals and related products. The safety-related critical systems are designed, engineered, and implemented to provide continuous safety against dynamic risks, to only be checked periodically, making it impossible to know just how safe you are. So the regulatory frameworks may vary by region, but the underlying principles of ensuring compliance to safety remain consistent. So a quick look at where we are today and where we've come from. The fourth industrial revolution represents a fundamental change in the way we live, work, and relate to one another. It is a new chapter in human development enabled by extraordinary technology advances commensurate to those of the first, second, and third revolutions. Now, these advances merging physical and digital worlds in a way that create huge opportunities. The speed, breadth, and depth of this revolution is forcing us to rethink how organizations continue to operate and maintain their assets, and at the same time, create shareholder and economic value. So we talk about going digital, right? So going digital, it's important that, we leverage data in the right way such that it can unlock untold benefits. Every digital initiative starts with desired goals and objectives in mind. Some organizations set out to improve operational safety and performance. Others seek to enhance critical risk-based decision-making processes, transitioning from prescriptive approaches, or most commonly, believe it or not, transforming to be more proactive towards safety management versus being reactive. In all these scenarios, it comes down to leveraging the data in the right way, such that it can unlock many benefits. As a famous British mathematician in the field of data science put it, data is the new oil, but if unrefined, it cannot really be used. So in a sense, harnessing data and converting it into meaningful and useful information for data-centric operations is the cornerstone of each digital journey. Through the use of proven technology and expertise, organizations can successfully get the most value out of their maintenance, reliability programs, minimizing unplanned downtime and failures to maximize uptime, production, and profitability. Automation of documentation streamlines compliance management, auditability, reporting processes, as well as reduces manual errors and administrative burdens, providing a robust certified framework for ensuring compliance to regulatory and insurance requirements. A lot of insurance companies, when it comes to risk management or loss prevention, also look for proof and validation of process safety management systems, functional safety frameworks, and we've got a few customers and partners here in the audience which have shown them SLM or functional safety databases as part of validating and checking the performance of those insurance companies. So with advances in intelligent work processes, integrated ways of living and working, it is long overdue that functional safety catches up, ending a long-standing era of fragmentation, disparate information, and data silos. And I'm kind of preaching to the choir because most people here are digital or on their digital journeys with SLM. It's also important to acknowledge that as well. So at the end of the day, the promotion is to work smarter, not harder, is to transition from thinking you're safe to knowing you're safe by establishing a sustainable safety management framework. Thank you for that. And any questions? Everyone's familiar with the journey. Everyone's well on it. Thank you for your time.
Thank you.
Yes, absolutely. So at the base level, depending on where you are, what engineering practices or standards are followed when designing facilities, to a certain extent, we're seeing prescriptive-based design. Now, moving to more of a risk-based maintenance philosophy is, once you have the data and you've identified your hazards and linking the operations and maintenance aspects of how you manage the operations phase, and seeing the direct impact on risk is more of the risk-based approach, right? And I think we've got some, Mr. Stephen Kearns mentioned from Shell is a part of their MOCs for brownfield facilities in the Gulf of Mexico. As they were implementing MOCs that affect anything related with safety, they could assess the impact within SLM to see what the level of risk was before making the change through the digital platform, because essentially you have a safety digital twin that's linked to your safety profile through a fully integrated system. So the hazard and operability studies, it's all pretty much linked. And so any change you can make, you have the ability to see the impact on risk. Now, also when it comes to prioritization, so if you're prioritizing your operations and maintenance work, you can see what the greatest impact will be. So if you have to decide between doing one task or the other, you can determine which one has the greatest impact on risk. If you decide based on your available resources, what are you going to work on from a testing standpoint or improvement or enhancement. So that's kind of, driving a lot of the decision-making process based on the risk profile that was established when this facility was designed and implemented. Now, moving that to a performance-based is once you've started collecting the data. We talked about proven in use today, maintenance history. Is based on your in-service data and performance of instrumentation or systems or even process unit equipment. You can extend testing frequencies or defer certain activities that you would do more frequently based on performance-based data as well. So that's prescriptive to risk to performance-based. Yep, absolutely. Any others? All right, well, thank you very much.
I was told that cookies and coffee are ready, so we wanted to make sure everybody gets cookie and coffees, or coffee and cookies. I'm not sure which way that works. More cookies than coffee, so we're gonna take a break now and then do cookies, coffee, and then do a user forum and a couple of more really quick presentations from MSS on a couple of items. But yeah, grab some coffee, have some cookies, get sugar, caffeine. grab a seat for the next couple minutes here, and we'll move on. Thank you very much. You guys using this? Turn it on.
All right, everybody, we're gonna get started in just a few seconds here. All right, the next person talking is Ayana. She's going to talk to us about the latest with our customer support.
But first, last call for cards. Question cards, last call. Anyone have question cards?
Any last question?
Okay. Hey.
Yeah, you do have to be present.
Hopefully everyone enjoyed lots of cookies, give you a little energy for the rest of the afternoon. So, again, thank you all for being here. It's such a pleasure to get to meet some of you in person and serve as your customer success manager. So with that, I'd like to go over some of the enhancements that we're making with the support center. And one of those things is Zendesk. So what we've done recently is upgraded the customer support infrastructure with a tool called Zendesk. And what that is designed to do is provide a central location for all your support communications. So in the past, where it may have been a lot of different emails going around on support issues, now our tool Zendesk will allow all that information to be stored inside one ticket. It gives visibility into the progress and the status of the ticket throughout the ticket lifecycle. In addition, there's a support portal that's available for you to review all your open tickets, and it'll also be used as a repository for future feature requests. So I'm super excited about this and the enhancement to the customer experience. So as I mentioned with the support portal, if you should have already been kind of getting tickets because we went live at the beginning of this quarter. If you use your business account to create a Zendesk client account, you will have access to all your tickets that are available, what status they're in. You'll be able to click on them to get additional information on the progress of the ticket, to immediately communicate back with our support team, let you know how the status of the ticket is going. So we're just hoping this will continue to enhance the customer experience and make sure we have good communication with our support organization and software development. So as I mentioned, this is actually already live, and you continue to open support requests similar to how you have in the past, either through the application, via a web form, or email, or even the support request phone number. Additionally, you can always reach out to those of us in Mangan Software Support as well. So super excited about the enhancement to the experience working with software development. Any questions regarding Zendesk? I didn't think so. It's pretty self-explanatory. Thank you. And now Chris will go over some enhancements in training.
All right. Welcome, everybody. It's good to see a lot of you once again. I'm here to talk about some of the latest improvements, or at least things that we are improving upon, developing for two main areas. One,
with a video knowledge library, and then the second just with online training. So just really quick, I'm curious, while I was in here just lately, maybe you're looking for, maybe you have a record player, a CD set, maybe 8-track, maybe a phonogram, depending on how far back you want to go, and you want to, you're looking up something, how it operates. So where do you go to find that kind of information, typically? Google, YouTube, there you go. You mean, wait, you don't pull up like the instruction manual or everything and try to read it? No. There, Kevin does. Okay, there we go.
As an engineer, I don't need to.
Okay. All right. So, actually, the same thing with me. I actually got a camera recently and was trying to figure out how to use it. I went straight to YouTube to figure out what the model is. So, same thing here with SLM, our knowledge library. We are developing videos to be able to just put out there for all of our clients to be able to look up and use. And, it could be as simple as being able to figure out how to add objects, delete objects, how to use checklists, bookmarks, but it's also more complicated. It gets into all the different modules that we're in, and you'll be able to figure out how to perform SIL calculations after building out your SIFs, or recording any of the events that you're looking for to operate and maintain. Videos on how you're going to facilitate your local or hazard. So videos on how to do many different things in here, and even things with the system module, IT, integration, videos on all those kind of things as well. So we wanted to give you an example. So we're working on it, it's a process right now, but I wanted to give you just a quick example of how one of these videos might look. Let's see here. Let's have to minimize this and bring it over. There we go. Just slide it over. Okay. Can you guys hear that?
This application explainer video answer our SLM one-to-one topic range. In this video, we'll be covering the subject of adding objects within SLM.
We have the voice right back there, Dean.
Objects in a template view, adding objects in a category view. First method of adding objects will be through the Edit Tools drop-down menu. In order to add objects with the Edit Tools menu, click on the parent of the object you wish to add. Navigate to Edit Tools and add your desired object. Next, type in the ID for that object, and if it's a new object, which it should be, if you're adding, then it should automatically say create new object as your option.
I think you guys know how to do all this stuff, so we'll skip it ahead a little bit. Let's see.
Feed directly into the table.
So it shows different methods on how to do it. But essentially, what we're looking at is just, in this case, add objects.
Press add sig, or as many sigs as you'd like to create. This method is good for adding lots of the same object types all at the same time.
So that's the idea. It's just a quick, overview of it. But with that video library, now you guys, I know you guys have a lot of questions sometimes, and you ask us, and sometimes, we're busy. We'd like to get back to you as soon as possible, but sometimes you need the answer right there. And so now being able to look it up on the spot with a video instruction makes it a lot easier. I know you guys love the nighttime reading with some of the study guides, but now you have the interactive videos there. So.
Video for integration. Is integration with the SLM with the other systems, or for what? What that integration means?
That would be, I guess, integration just in general, perhaps with other systems. Steven, you want to talk more about that?
So the video over integration is going to be like over the API and also over the CGI that we develop,
Right.
So I already started on integration stuff for the video. Kind of show you how the CGI works for our partners, how to configure, how to set up, how to install, how to run and maintain.
Okay, so in the future, we will be able to troubleshoot.
So it's not her question is, where can you guys access this? So I'm glad that you asked that. Very, very well placed. You can access it. It's not up there yet, just so you guys know. We're developing it right now. But where it will be is on our website, mangansoftware.com. You'll be able to find it by going under training and then being able to go under just being able to see all the videos there, or mangansoftware.teachable.com. So that'll be the portal where any of you guys can go in, just create an account, username, email, and then sign in and watch any of the videos that you're looking for. So that'll be right now we're slated for mid Q3 to have those videos up there. So whenever it's all ready, we'll be able to send information out to you guys. Okay. So next, with training and being able to discuss things dealing with training in terms of the online aspect. So right now we have live training, whether it's in person or online, and the training is accredited from RCEP, the Registered Continuing Education Program. So that gives us the ability to offer professional development hours for those courses that meet those requirements. Now, with online training, we'll follow that up after we build a video library, and then what we're looking at first is being able to certify the basic courses. Basically, we'll put together a series of videos, have an assessment afterwards, because basic level is kind of like an awareness level of how SLM works. And then eventually, with the professional courses, where it's going to be more interactive, there will be a harder assessment where you're using a set of rubrics to be able to determine, okay, do you meet these areas with these different exercises that you're doing? But it's going to be self-paced, essentially. So whenever you have I guess different time zones, and you're like, well, we have this person here that needs this training right now. When is your next training? Oh, okay, you're booked, so let's do an online training, self-paced. So that way you guys can get that one person trained or whatever it is. So we'll be able to meet the qualifications, or I guess for both of those types. And so, like I said, we're looking into the accrediting for the online self-paced training as well, so you guys can receive professional development hours for that too. And you might be wondering, where are you going to find that? Well, right there, same portal on mangansoftware.com. Training, you'll be able to register for any of the training courses and sign up and be able to see any of that stuff. So with that, are there any questions? Okay. All right. Thank you, guys. Thanks, Chris. I'll hand it on over to Sean. He'll be moderating the user forum for you guys.
Yes. All right. Exactly. All right. So for the user forum, we pretty much just want to have an opportunity for everyone to have open discussion with some of the questions that you guys have asked and written down on your cards. With that being said, to incentivize you obviously to write on your cards, which a lot of you submitted, we do have drawings. So what we're going to do is the first card that is drawn out of here, we're going to give a Bose speaker to. And then second and third place, we're going to get these awesome SLM water bottles. So who's to say whether you want to be the winner or the second or the third, you don't know. So in these We have lots of them to get rid of any bias due to anybody maybe trying to pay people off for the raffle. We will let Mr. Ramon please roll the first card. What is the name on it? Ramon. Carolina. So Carolina's question was, how will we protect confidential information from discovery from some of the AI models that I think Jeremy was talking about earlier? So Jeremy, I don't know if you want to talk, if you want to pass the mic around, or if you want to, I don't know if anyone can hear you.
Sure.
Whatever you want to do.
Sure, it's a great question, and yeah, this is a really interesting problem, and one that obviously we see a lot in just IT in general, right? And Carolina and I were actually talking about it over lunch, so we were talking about this over a couple of sandwiches. The issue we find, of course, is we start exposing all of these disparate data sources to a system that can actually understand the information and the data. There's a lot of those locks and keys on some of this data. We were saying things like, okay, well, what happens when we want to have access to financial information? There's going to be locks and keys that are going to be placed on it. That's one part of it. The other part of it is how are we going to make sure this data is not exposed to nefarious outside actors? And in both of those cases, you're going to have layers and layers of security that are going to have to be applied. That is one of the difficulties with any of these technologies, especially when it comes to, as you guys are probably seeing with integration. Each time you try and get more data out, it becomes even more complicated because you keep adding more layers of security that have to happen. And I mean, we see it all the time, right? You guys are seeing, and all of a sudden something drops or something stops working. And why has it stopped working? Well, because somebody changed the password on another system somewhere deep down, and it's no longer, your integration is no longer working because it's no longer responding. And who controls that, who manages that, that's all a very complex and difficult thing, but something obviously we have to continue to work on and keep looking at. That's a great question. Anybody else have concepts around that, want to add to it, take away from it? No?
Build on your question, would that, so the API would be able to feed into a private kind of a self-contained AI module?
Yeah, that is typically the way we're looking at it, the way we're sandboxing, right? And we're all kind of putting everything in sandboxes at this point. Yes, you would want to probably in a lot of cases when you're exposing and working in AI environments, you're sandboxing the applications, you're sandboxing the data, and initially you obviously have to go through it. Something called red teaming, where you're looking at the data and making sure that you're not getting anomalies out of that. But yes, absolutely. It's going to be mostly, I think a lot of it's going to be on-prem. You're going to probably be interconnecting with your own models that you're developing. But you may also expose it to public models. I mean, we all hear of ChatGPT making wonderful, awesome images for us. Those kinds of things are one side of it. But really, a lot of it, what I think you're going to see more and more often is your own organization is going to start developing their own internal models, and that's where you're going to get that exposure is internally. And you'll probably hear about it. You'll probably hear in the halls, people talking about, oh yeah, they're working on this AI model that's connecting to our ERP or to the maintenance system, and that's where we want to make sure that we're ready to expose the data to your own internal models. Yep. Question number 2. Ready?
No.
Go for it.
Rolling. This would be from, I believe, one of our Nigerian dignitaries, Lottie? Yeah. So the question that they have is, how do you use SLM to ensure that HAZOP and other PHA action items are followed up on? So I know obviously this is something that maybe some of you guys use with recommendations and gap closure tracking, but I don't know if any of y'all that are using the HAZOP or LOPA modules could maybe speak to that a little bit more, or, see what that looks like. Here goes, Mitch.
Yeah, that's exactly how we do it. We actually have our database. It's called CARE. It's an audit action type of database. And so when we have something that comes up like that, we put it in that. It's got a due date, just like anything else, and we track it. Of course, you get lots of badger mail as it gets closer to make sure that you've got it taken care of. But that's what we use. It's called CARE, and that's how we handle it. So.
But that's independent of the SLM?
That's independent.
Yes,
That's independent.
yes, independent.
But I think that that should be similar to how we track action item from FSAs.
Yeah.
In SLM. Yes. That should be very similar.
Yes.
So that's,
Yeah,
you are overdue, so it's gonna start basically.
Yeah, and that is a piece of the SLM system, is being able to capture and add action items straight out of your HAZOP or LOPA to look at those recommendations, and then be able to track who's been assigned to actually go through and evaluate them, close them, what the status of those is, are they done on time, all of that. So within the system, you can run reports and see dashboards of how many open items do we still have, how many are needing to be closed, how many are overdue, all of that kind of information as well. So. Any other thoughts, Matt?
Yeah, that is, the action item tracker module is a module in and of itself in SLM, and it can be used for that. Motiva has decided to use their own system for it, and that's perfectly fine. Anybody else can use their own system as well. We're not going to force y'all to use something you don't want to, or to adopt something new. If you've got something that works for you, great, that's fine. Anything that we're identifying as specifically with HAZOP and local recommendations, we're just going to automatically put it into the action item tracker module in SLM. It's up to you whether you want to use it or not. And that goes for a lot of data points in SLM. If you want to use what is in there, go for it. And if you want to make modifications to it or have suggestions to improve it, we're all ears. We'll make those modifications as long as they align with what we're trying to do with the product. But then if you want to use something else, okay, that's fine. We'll accommodate to whatever you want to do.
Any other thoughts?
Just a shout out that you helped us use that action item tracker. We had found it for very deferred FSAs that needed to get done. But we did all the action items right there on the fly while using your FSA module. And now their maintenance manager, he pops that up every time we have a meeting. Show me the action items and uses that action item. So, and what's nice is it's embedded into the same software. We're getting good run time.
Good. That's good.
Yeah. All right. All right, and for our last water bottle. To all you are engineers, some of your favorite. Manuel? Yes. Oh no. Yeah, I do. The question was for this, it's how do you use regulations to drive SLM, and how effective will SLM be without a high-speed internet service? Right. So for regulations and driving SLM, I don't know if anyone wants to speak to that, Matt or Jeremy, but obviously as the standards continue to change and adapt, we look at our software and how it can help, continue to guide along those standards. So updating, like Matt was talking about, some of the automated features around the hardware fault tolerances, the systematic capability, trying to move with those standards, but
Certification 2, you have to recertify every 5 years.
yeah, which we just recently went through our TUB certification, getting it recertified to meet those safety standards, but always adapting as the standards continue to change.
Yeah, Exactly. 61511 came out with a new edition years ago, and we came up to the point of having to recertify, so we had to just make sure that it was still aligned, and we went through that. And if something changes, you know, something bigger changes in the standards, we'll make that change and make the accommodating change in SLM as well to make sure that they continue to align. There's not much more to it than that. It's just a continuous process, just to make sure that that it is aligned with the standards. So.
Let me ask it a different way, maybe. So if someone was to do an audit, it could be internal or external, and they wanted to see how close you were to closing, how much risk there was as far as gap closures. Is there an easy way for it to spit out the difference between having no deficiencies versus a risk reduction factor gap of, say, 1.5 or 2 and a risk reduction factor gap of 100? I mean, is there an easy way that it could facilitate auditing and the overall risk gap? Because typically when we do enter these things in, it's not that everything's perfect unless you're only in the project phase, right? But if I go to a site and want to know where your gaps are, the one way is you show everything that's off, right? Another thing is I can go to one of our sites and it says, oh, well, there's 200 things that are off. Well, if the average amount it's off is 1.1 or 1.2, we might have, as a company, said, okay, the difference between testing every 30 days and every 25 days is not significant enough to justify trying to adjust SAP or whatever the maintenance system is, versus, hey, look, when I go in for the audit and you're missing 100 risk reduction factor of 100 or 1,000, that's really critical when I do my audit, right? I mean, is there anything in the software that helps either internal audits or external audits flag risk factors?
Yeah, so there are various reports throughout the system that looks at some of those comparisons. So specifically, around SIL calculations, show me a SIF that's not meeting its SIL target and show me the difference between those. There's also reports from an SRS perspective of these are recommended fields from IEC 61511. How many of them do we have populated versus how many of them are we missing key components as part of our SRS? So it just kind of depends on the data. It goes back a little bit, I think, to what Jeremy was talking about previously, also around some sort of safety conformance score for your entire facility of, hey, how many things are deviated from where they're supposed to be? This facility is an A or a B or green, red, yellow, whatever that may look like.
Bring it down to the unit level.
Yeah.
Start being able to drill down.
Yeah.
Yeah, if you're talking about like SoCal gaps, there's 2 reports in there that I designed a few years ago, and they have deltas, like differences, so you can sort by deltas, both for exceeding RF target and for not meeting it. So if you have higher priority items, you can use that table and just sort and see which ones are severely failing versus the ones that are pretty close. No delta, just off by a little bit.
Yeah. Yeah.
Yeah, part of our cleaning of our database, we went through the process and we generated that report for all the SIF, non-meeting SIF targets. We were able to see prioritize to identify what the problem is, what the problem was.
Any other thoughts, questions on the same thing?
Did that answer your question, or did you have a different question?
Well, I think that's what you were asking is how can we use it for auditing to flag deficiencies, right?
Mm. Yeah.
How can we easily do internal or external audits and show risk?
Yeah. Yeah. Yeah.
One quick way is if you have PHA data in the system, you can immediately see just on a risk matrix, where are my gaps right now? How many scenarios are in a status where there's a high risk? Just by placing it on a matrix of severity versus likelihood, and its residual likelihood, after IPLs and barriers are applied, even recommendations, you can see that, do I still have a bunch of scenarios that are, within a, quote unquote, red step of that severity and high likelihood. So then you can focus down to the individual scenarios at that point and go back into your PHA source data from that point and see what the scenarios are and what you're doing to mitigate.
But in order to do that, the risk management, with the dynamic risk management, you probably need to customize that one to basically adapt to the company risk management.
Oh yeah. No, every instance that we stand up, that's an option, or it's not an option, but it's pretty much one thing that you do need to put in if you're going to put in PHA data is to configure the risk matrix. And we went over that earlier about one thing that we're going to do coming up soon is put more resolution to that risk matrix to bring it down to the individual PHA study level. So then you can have one PHA study that has a certain risk profile, and then another PHA study where the risk profile might have changed, that matrix profile at least. So then you can have different sites having different risk matrices if that's what's necessary, or even past and current risk matrices as they change.
I don't know if that helped there.
I thought his question was more about aligning to the regulatory standards, not identifying the particular risk profiles at any given time. I thought it was good too. Questions that they much better address there.
Naive question, doesn't the spider diagram in the FSA module give you the procedural questions versus the technical, and a lot of those questions are based around the 61511. So by looking at that spider diagram, it's been a while since I looked at it, but we were playing with that. It seemed to give you a spider diagram score on the
based on the FSA
questions.
I think isn't that comparing the self-assessment to the actual results though?
Well, no, they'll show both the self-assessment and the
those are check lists, right?
FSA.
Those are the check data you have on each FSA.
Checklist will generate that.
And those questions are wrapped around compliance.
They are.
Yes. So to me, that's a very nice low hanging fruit and low hanging fruit. Yep. How well they're close. If you haven't seen it, it's pretty nice. It's a good vision.
Thank you.
Even though I didn't get a lot wrong, that's okay.
All right, from Chad has a question about will we ever be allowing importing of PDF files or JPEGs directly into SLM instead of the native flat file piece? So, I don't know.
As an import.
As an import, as part of the import. I don't know how that would work in terms of reading the file from an import perspective. Midas or
We do have
some AI tool.
some technology that we use for PDF.
Yeah. So the issue with that, I think, is when you're importing things like a PDF or a JPEG, the SLM system has to understand what data is flowing from that native file into the fields that exist in SLM. So if you're using just a flat picture, it's got to be able to pick out, hey, this is the CIF ID, this is the description field, this is the SIL target. All of those fields have to be recognizable. And so in those different formatting types, it can be difficult to understand where they're supposed to go. That's why with the flat file and the CSVs that we use, it's very straightforward of this column is object ID, this column is field number 1, field number 2. So I don't know if there's a way to actually ever import them. It would really be more efficiently converting them.
Well, there's preprocessors, right?
Yeah.
We use Midas as a preprocessor.
Correct. But something built into SLM, yeah, would be.
I think that's probably more you're headed down that AI.
Yeah, more towards the AI.
Yeah, we've done some work over the last year where we're using preprocessors to convert PDF text files into readable format files in order to import. And that's all been the preprocessor is not manual, but it is a manual process to identify what data points that it senses where they go. one of the steps that, or one of the secondary phases we were attempting to get into, I think we might still do this, with that technology is to place that preprocessor or link that preprocessor into the SLM adapters technology so that we could just upload a PDF, identify what fields go where, and then let the system convert that file over and import it in one swoop. So there's things we can do. How much are we going to actually accomplish that before we actually get AI work to do it for us? So we'll see what the next year and next year or two has in store for it. But it is something, Chad, that we are looking to do, to make progress on for translating or transforming data from PDFs or even potentially from photocopies into digital versions. So, yeah, we'll see what we will accomplish, but it is something that we're continuously working on.
Nice. Monica's asking, when will authorized users be able to create kind of custom reports and workarounds for that? Right now, it's pretty much what we have in the system. I don't know if there's any roadmaps for more customizable features within the reporting.
That's going to be with the CSS endless reporting, API reporting. We'll get better customized user configured. I'll use that word. User configured reporting around that technology for anything else.
Yeah, and I think the important part on that is, we want to focus on, obviously managing the safety lifecycle data, managing safety lifecycle information, and making it available and accessible. I think you've seen a lot of the discussions we've been having here is to make the data accessible for you. So I think the goal here is, in the example that we're looking at would be, you see a report in SLM that you like, but you want more of the data fields to be represented, right? Or you maybe want just a different pivot on that data. So give me this data, let me put it into my corporate reporting tool, because there are, as we know, probably like 10 or 15 major companies that all they do, their entire software package is to just make pretty reports or help you build a better report. We're just going to be the data side of that. So we'll show you how you can call that data, access that data, make it accessible through SLM, so you can take the data and make it look however you need to make it look for your report. So making the data accessible is what we're focused on, and we're not necessarily focused on, we're going to build the greatest reporting software in the world. That's not what we do. So you'll plug it into Tableau or you'll plug it into Power BI, because obviously those are going to be where you're already using. So we're just going to try and make sure the data is accessible and easily accessed, and you can say, hey, I need this report but in a different way, or I need to combine these two reports. So grab the data from the two reports, bring it into Power BI, and make the pretty picture for yourself.
Yeah. How will we know when these things are come to fruition? I guess it's a great question. You guys have you thought about doing maybe I don't know, newsletter, some kind of something for folks that are they're your customers of yours, and so we can see that kind of stuff as it comes out.
Yes, yeah, and that's one of the things we're moving towards. Is we're doing a lot of the video work as well. We're also doing video release notes. We're starting as new features come out. I don't know if you guys are noticing, we're kind of beginning a much more advanced release process. We're trying to do basically a release of additional feature set and functionality just about every month. We're updating a new feature, or some new features are coming out. And as we go through that process, we're going to start broadcasting that. And we've got a couple of different things that we're still previewing and trying to get the format correct. But each customer typically they may have a couple of defects that they put in, or something that they have that they may be working on specifically, let's say for Motiva. We want to make sure that you get your information, as well as maybe Chevron has an update that they want to have. So that kind of information would be provided to Chevron, provided to you, and then the core information then provided to everyone.
Great.
But yeah, we're going to be starting to do a lot more communication around what's coming out, what's coming down the pipe. Yep.
Great. Thanks.
All right. Sticking with the reports, Nigel's question was kind of like around specifically like which are some of the better management reports that are within the SLM system that you guys are more often than not using or showcasing. So I don't know if anyone can speak a little bit to that from the guys that do a little bit more of the reporting aspect, maybe things that you're asked to compile that SLM helps get, or things that you're asked to compile that SLM doesn't have, you know, whatever that may look like. But
One of the most that we're asked about is the SIP list.
Okay.
When the PSM group's doing PHA, we send them a SIP list for that unit, and it has the target still rating and achieve still rating, stuff like that. We get asked for that report a lot.
Okay.
You guys built this one for the KPIs,
Mm.
and that's handy. That's a monthly report we send out to our customers.
So are you manually taking each of the widgets and compiling it, or are you able to generate that within Sling?
You can just generate inside there. Yeah, it asks for a date range, and it generates the file for you. Yeah. Date range, or in the case of the SIP list, it's you pick the unit that you're and it throws all of them out there so you can see it.
Glass of scotch, I think you'll get it.
Yeah, possibly. Yeah.
Okay. Any other examples of any reports that you guys see or use? Kevin, I don't know, Chevron, if you guys have specific reports operationally that you're collecting from each of your instances, or?
Right now it's done manually. Yeah, we had talked about years ago trying to have a single one that everything reports up. I'm glad to see you're making progress with that.
Yeah. Oh, one of the other ones that we use is also is the SRS. If we make a change to one of our SIFs, I'll send that out to the person that requested it, and then we'll actually put that into our our notification. You know, basically our deal showing that this is what we finished it up, completed it by, and that's the I guess proof and pudding right there to show what it looks like.
Gotcha.
And there's also the still verification.
Yes.
And also the auto effect.
That's fantastic.
Yeah. Yeah. Ramiz, I don't know if you have anything specific. I know we've obviously been talking about some of the reports and lists.
The one that comes to my mind is what we call the total protect us against the major severity of box. So we have a report that shows the IPL from the DHA and the scenarios that IPLs protect us against. It's pretty neat, and we also utilize the WebView link. So we created that WebView link so it's accessible from anywhere. Or whoever has that link doesn't need to have access to SLM as such, but you can quickly access the list of our second.
Gotcha. Very nice. Any other reporting questions, thoughts? Anything? All right. Stephen, I see you have a question here about creating a set of, non-safety regulatory devices. I don't know if you wanted to expand on that or.
No, I think it goes back to what you said. I mean, you're collecting data and trying to put it out, but I mean, I know, like in the Gulf of Mexico, there's a number of companies, and that we have separate software just to collect the data for the regulator, and it overlaps a lot with the testing of all the safety devices, and that's the go-to place for actually most of our information on reliability. And it doesn't sound like you guys are looking to be specialized in any specific type of reporting, but you want to just interface. So I was just curious if your goal was to replace some of these reporting companies or just interface. I don't know if you answered that or not.
Very nice. Very nice. Mitch, yours was we're going to convert test procedures into smart procedures, so knowing more about how to load pre-formatted test procedures into SLM. I don't know if you want to expand on that, or if Matt wants to talk about obviously some of the stuff that I think was in one of the slides about the test procedure
Yeah, I
checklist.
think a little bit. Kevin had kind of gone over that. I've written that before he did his presentation, so it's something that we're interested in because we're getting involved in our new online test procedures, and I'm really interested in trying to get that data over to SLM where it can become an automatic function of grabbing the failure data and putting it into SLM automatically. And I know I have a second part to that. It's that both of them were not questions, but they were
thoughts.
And so the second part of that, and the reason I brought that up, my second part was, when are you guys going to give us a site license?
So his point is the more data he's got in it, more data he's got in it, the more people are. And so that actually flows into another question that we have from Devanka is, how many users do you guys have active in your instance, or how many are you needing to have
Right now,
access?
we've got 3 seats, but I'm seeing especially as we're going forward with this and trying to get more data in there and people need to access it. I could see very easily 15 to 20 people that I need to, have access to. Our control system engineers going in and actually entering the data for these troops that we have, right, and looking at that stuff. So that's kind of what I was looking at.
Yeah, and so that goes with Devanka's question about, power users or number of view-only users or that kind of thing. But as the more amount of data that you're bringing into the system, the more people are going to need to be actually working within the tool itself.
And Phil knows he's been working with us on this piece, but the cause and effect drawings, they're evergreen cause and effects, which is wonderful. So I mean, some of our drawings at TiVo or they lack a little. Okay, so with this, lots of our folks use cause and effects. I mean, that's a great place to go gather your data. It's going to be every place we put our set points. We're going to put in our ranges in there for all of our transmitters and such. It just needs to be accessible to the folks that need it. And it will be. I just wanted to, I just wanted to see if there was something coming up that, we have a site license for several other things that we have, right? Other things that we do, right? Yeah. And I just was curious.
Have you guys run into any licensing issue where you actually get?
We do. We get bumped out. We got enough now where like Ramon is over there, me and David and Jerry.
So it has the lockout because there's a feature where we can disable the lockout and you can actually find out how many you need.
I see.
And then it'll allow you to basically bypass and go over the total number of users that are in the system.
Right.
And it's just reporting it, figuring out what's going on, and then you can come back when you go for your renewal. We can say, hey, look, you have 3, you need to have 5 based on your usage, and then you have 5.
And with all the work that we're doing right now, there's a lot. We will.
I'll write it down.
Yeah.
Okay.
Which I can reach out to you and we can talk more about that and see what would work.
Some of that is done through the API. You can make calls and get data from the API. But I mean, you may just want to say, hey, look, I want to log in and be able to have access to it. Just making sure that.
I don't think people are going to be in there all the time, but it's just when you do need it, you want to have access to it.
David, your question was about test procedures, including inputs, logic solvers, outputs, complete tests, or just individual selections. I don't know if you want to expand on that a little bit, but.
Yeah, like when our test procedures right now, when we will drive an input and see an output happen. So is this going to be all inclusive in these test procedures, or are they going to be compartmentalized? You can only test inputs, you can only test logic solver, you can only test outputs.
Matt, correct me if I'm wrong, but I believe the way that it's set up right now is for the test group, whatever instruments are a part of that test group, then the procedures that are associated with those instrument types would then be available for that test group object. So if you were testing only inputs, only the level transmitters, then you just have those procedures. But if you were testing it all, or is that not completely wrong?
Yeah,
We have
test the whole
we have our test group separate.
Yeah, so
input, logic, solver, and output. Separate testing groups.
Separate testing groups. Yeah. So you're testing groups, it's just the inputs in one group and the outputs. So in that scenario, because the inputs are associated with that one group, then that one group would only have the testing procedures for those instruments that are in that group, which would be the inputs, those procedures themselves, I believe. But I don't know if that answers your question. Joseph, you had one about implementation layered programs, leveraging SLM to implement Odell. Your layered programs leveraging SLM to.
If there's multiple standards, their workflows or process to, to compare those, if there's multiple standards that, they're trying to comply with.
regulatory standards or just company standards?
I'm just trying to get an entry into
He's trying.
I think we covered it, I think we covered basically talking about regulatory standards, so.
Okay. Stan's got one for better print features. I think not necessarily a question, more just things to think of and consider. Obviously, I think as some of our reporting's changing, we've talked a little bit about that. Kevin had one about failure rate collection data analysis. Oh, there he is. Kevin, your question about failure rate collection and data analysis, I guess that would go back to some of what Matt had talked about trying to provide maybe some of those manufacturer failure rates as part of a piece to have in the tool, and then obviously continue to collect and expand all of the instances. I don't know if you had other layers to it.
Well, the other thing is, right now, there isn't, when you do the prior use, it just collects all of the failure modes evenly, and you can't necessarily exclude some failure modes from that analysis on the failures. So it would be nice to have a little better control over which failure modes would be considered, dangerous failures.
Just recently, the last month or so, got a similar question from the guy who presented earlier, Mark Maturdo, around that same concept. He was asking if, or he was suggesting to allow on event tracking to allow failures to be identified as either contributing to the failure rates or not contributing, whether they're random or systematic type failures. And so yeah, I mean that's I respond to in the affirmative that we'll look at that capability so that we can get better resolution on that on the contribution of those types of failures to the failure rates. That would be good.
We have one from Lena, obviously. It says, what makes Mangan different from other competitors? Obviously, I am maybe a bit biased in that, so I'd maybe let some other people speak to it, as there are a few other products in the space, but, you guys are the ones that have gone through some of these evaluations and have continued to, look and use the SLM product. So if anyone wants to say good or bad,
When I did the evaluation for the different tools in the market years ago, so there was another tool in the market that I asked them for integration capabilities. So they said that their tool contained everything that I needed. So they really said that we didn't need to do any integration. I was asking about integration, for example, with PHA Pro, with SLP, PI, and they said, no, our tools stand alone. So we have all the modules that we need. I said, well, I'm not going to select this because I'm not going to afford, for example, PSM to use this safety lifecycle tool to conduct PHAs, where PSA already use their own tool, PHA Pro. Instead, so I need to have integration capability in order to basically import data from PHA. So what's integration capability for my automatic tracking event, for example, by integrating with historian system. So that basically, I saw a difference. So yes, with the other tool, and that was one of the reasons I said, well, it seems like with SLM, I have more integration capability, so I can do more development and optimization of my system rather than having just a standalone separate.
Yeah, well, I would like to that. In our case, in the experience just we have, is the flexibility to that. For example, I remember the based on all the different variables they order their food. They ask for that, and we got it. So I think in the business, you are need to be flexible. Things are changing fast. People's gonna ask for more.
Yep. So also was the what's called cost. So the other competitor, so they charge you per seat, over a seat, and also the processing speed. I see other tool that when you start adding more and more data, so the tool basically the processing is very slow comparison with this one. We have been loading a large amount of data to our database, and the speed is the same all the time. So we don't have any issues with processing speed.
Very nice. Thank you guys for sharing. The only other ones that we have are going back to AI. So we've already kind of touched on them a little bit, but there were some just about us deploying them. Where do we see it in 5 years? What confidence do we have in the accuracy of their, abilities? And obviously, I think we've talked a little bit about that, but it'll depend as that technology continues to grow and change. But yeah, but that's all the ones that we've got. So.
Sure. Okay. Well, everybody wants to talk about AI. Yeah. So I think, and we did talk a lot about this. Where we're seeing it in the next 5 years. I think we've all probably played with some of the tools. What we're seeing is, I think I've said this before. A lot of organizations are beginning that process of understanding where AI fits within their own organization, how they're going to be exposing this data, and I think it is very much at its infancy. Very much at its infancy. There are a number of tools out there that today you can take just about anything, images, JPEGs, your database, your raw data set, your raw database, plug it into commercial AIs, public commercial AIs, and get some information. The problem we end up with, of course, is we get some of these wild answers that don't necessarily match what we're looking for, and that's where what will have to happen and what needs to happen is the data model themselves, more specific models that are trained on your data sets. You have to do the training. You have to bring in the knowledge base and say, this is my data set and this is why it is what it is. And you need to train your own internal AI to understand what that data is. That's why we're going through the process of building out that accessibility model, so that we can train an AI based on the data that we actually expose, and not necessarily just some generic, like these big ChatGPT generic, information models. You can ask ChatGPT today about anything to do with process safety that's pretty much documented on the internet, and it will give you pretty good answers. Pretty good answers. Very close. Sound like, a junior safety engineer. Sounds pretty, very, very close. And they'll be able to do silcalcs for you for the most part. A little bit, but they can do some of it, right? But again, it's generic. It's not necessarily specific to your data, and it's also not necessarily going to be specific to how you want to represent that information to your audience, right? So I think, again, it's going to take time and training, and what we're working on right now is making that accessible so that you can go through that training and then linking it to your disparate systems, your ERPs, your SAP system, your maintenance management system. So we want to be a part of that, and we certainly want to have those discussions and work with you and let you know that we're actually going down the path of trying to expose the data, not yours, but having the ability to expose the data to an AI for you. Yeah. So, any other questions around that concept, or is anybody terrified of AI? Anybody not want it to take their job? I know my programmers don't want it to take their jobs.
It's gonna be a learning curve.
There is a huge learning curve, yeah. Was that the end of the?
That was the end of all the questions, but again, obviously, as we continue to talk, if you guys have any other thoughts, questions that have popped into your head, again, features you hate, want to see added, things that are needed, anything, we're welcome to talk about any of it now, but that was the end of all the cards that we had.
Well, I wanted to take a quick moment to thank Ramon and Motiva for hosting this event. It was absolutely fantastic. So thank you very much. And finally, I have to give out a huge shout out to the person who actually did all the hard work behind the scenes for this, and that's Regine Blackmar. Thank you, Regine. If you guys have any questions, like you said, shoot us an email, grab us, and we'll be more than happy to help you out. So thank you very much for coming. We really appreciate it. Have a wonderful, safe drive home.
Thank you.
Thank you.
Congratulations.